When the first deep-field image from the James Webb Space Telescope was released, the world paused. A single frame captured thousands of galaxies, bright, organized, impossibly old. Scientists expected to see chaotic smudges of newborn stars. Instead, they found mature cosmic cities already glowing in full structure. It was more than a photograph. It was a question that reached across time itself. For the first time, it seemed the universe might remember things older than its own beginning. Each pinpoint of light carried a story written billions of years ago. The photons reaching Webb's mirrors had travelled more than 13 billion years across expanding space. Yet something about them didn't fit. These galaxies were too massive, too luminous, too organised to belong to a universe still learning to exist. Models predicted darkness and chaos, not beauty and balance. The image left astronomers stunned and the rest of us wondering whether the universe had just betrayed its oldest secret. At first, many believed it was a misunderstanding. Webb's instruments were new, its vision untested. Perhaps the light had been distorted by cosmic dust or magnified by invisible gravitational lenses. Yet every reanalysis told the same story: the galaxies were real. They existed when by every model of physics they shouldn't have. What Webb captured wasn't an error. It was evidence that the universe had built itself faster, denser, and earlier than any theory dared to predict. For cosmologists, it was like finding fossils of cities buried beneath the ruins of creation. Each new image broke another rule, pushing the dawn of structure further back in time. Some galaxies appeared when the universe was less than 2% of its current age, a heartbeat after the Big Bang. No simulation could explain their maturity. The deeper Webb looked, the older the cosmos seemed to become, as if time itself had folded to reveal something that came before it. As the data poured in, the mystery deepened. Webb was not showing a young, chaotic universe. It was showing something already mature, as if creation had skipped its childhood. Galaxies only a few 100 million years old shone with the brightness and structure of those billions of years later. Astronomers began to question everything from the timeline of cosmic evolution to the nature of time itself. Could the universe have started long before the Big Bang we think we know? The standard model known as lambda CDM could no longer hold the weight of these discoveries. Its equations predicted a slow, steady climb toward complexity. Webb revealed a universe that had sprinted instead. The rate of growth, the density of matter, the order of early galaxies all defied expectation. Some scientists spoke cautiously of new physics. Others, more daring, whispered of something older, a hidden era that left traces behind. Whatever the answer, it was clear. The story of creation had just changed. For over a century, the Big Bang had been the unshakable cornerstone of cosmology, a singular beginning where space-time and matter were born together. But Webb's discoveries began to unsettle that certainty. If galaxies appeared so soon, perhaps the clock of the cosmos wasn't ticking the way we thought. Some theorists proposed that our measurements of expansion, the Hubble constant, might be wrong, making the universe older than believed. Yet each correction only broke something else. The cosmic microwave background still fit the old timeline perfectly, but Webb's galaxies did not. Adjusting one side of the equation tore holes in another. It was as if the universe had written two versions of its own history, and both claimed to be true. Across observatories, astronomers rechecked every signal, hoping for an error that never came. The evidence stood firm: the early universe was too complete, too advanced, and too awake for its age. Something fundamental was missing. The hunt for answers began almost immediately. Teams across the world revisited Webb's data, comparing it with Hubble's older images, searching for any sign of misinterpretation. Could these bright galaxies be illusions, closer systems magnified by gravity or distorted by cosmic dust? The idea lingered for a while, but the evidence refused to bend. Webb's instruments confirmed the same results again and again. Each analysis only sharpened the contradiction. The galaxies were real, and they were impossibly ancient. When the last doubts faded, a new realization emerged. Either the universe had formed its first structures far faster than physics allowed, or our entire understanding of cosmic time was incomplete. In quiet observatories, scientists began to speak in lower tones not of errors but of something deeper, a missing chapter in the story of creation. If the Big Bang wasn't truly the beginning, then perhaps it was only the latest echo of something far older still pulsing beneath the stars. As Webb peered deeper, it began to capture faint ancient glows that defied easy explanation. Some of the earliest galaxies weren't just bright, they were chemically rich, filled with elements like carbon and oxygen that should have taken billions of years to form. These weren't the first stars the universe was supposed to make. They were already generations old. Their light carried fingerprints of stellar death and rebirth written long before time should have allowed it. Something had come before. Astronomers began calling them ghost stars, ancient systems that seemed to remember a history the universe had forgotten. In every spectrum Webb analysed, those same chemical traces appeared, hinting at an inheritance from an earlier age. The cosmos, once thought to be a blank canvas after the Big Bang, now looked more like a recycled tapestry. Perhaps the matter we see today isn't new at all, but the remains of a universe that lived, died, and somehow passed its memory forward. For decades, astronomers believed the newborn universe was simple, filled only with hydrogen, helium, and traces of lithium. Heavy elements were supposed to appear much later, forged in the hearts of the first stars, but Webb shattered that timeline. In galaxies that formed barely 300 million years after the Big Bang, it detected oxygen, silicon, even iron. These are the ashes of ancient stars, proof that stellar generations had already lived and died when creation had only just begun. That discovery rewrote cosmic chemistry. The early universe was not a blank slate slowly learning to make complexity. It was already rich, layered, and alive with fusion. Some scientists began to wonder if this meant the first stars were far larger and shorter lived than expected, burning through their fuel in violent bursts. Others whispered something bolder, that the universe had inherited these elements from a previous cycle of existence. If true, then even the atoms in our bodies are older than time. The deeper Webb looked, the stranger the universe became. The first galaxies it revealed were not crude gatherings of gas and dust. They were refined, balanced, almost elegant, complete systems glowing with the order of cosmic adulthood. In some faint spirals and rotational patterns emerged the kind of symmetry that should have taken billions of years to evolve. The universe, it seemed, had skipped its infancy. Creation's earliest pages were written in handwriting far too steady for its age. Simulations had long predicted chaos clouds crashing together, galaxies colliding and stars born in violence. Yet Webb showed harmony where there should have been disorder. To many it felt as though gravity had found its rhythm too early, or that some unseen influence had given matter a head start. Whatever the cause, the result was undeniable. Order appeared almost immediately after the supposed beginning. The young universe didn't stumble into complexity. It seemed to remember how to build it. Among Webb's earliest findings were galaxies so massive that they rivaled the Milky Way yet existed when the universe was barely a few 100 million years old. By every known rule of physics, there hadn't been enough time to build them. Matter couldn't have gathered, cooled, and collapsed into such giants so quickly. Each galaxy seemed to break a fundamental law of growth, standing as quiet monuments to something far beyond our current understanding of how creation unfolded. To explain them, scientists proposed extraordinary possibilities: accelerated dark matter clustering unseen bursts of early star formation, even primordial black holes seeding galaxies from the start. None fully fit the data. Webb's images whispered of a cosmos that worked faster, stranger, and perhaps older than anyone had imagined. The weight of the impossible was no longer just a metaphor. It was visible, shining in the dark, daring the universe to explain itself. If these massive galaxies existed so soon after the Big Bang, they must have started with something extraordinary. Seeds heavy enough to pull matter together in record time. Astronomers began looking for clues in the faint halos surrounding them. There, hidden in the deep red glow, were signs of something even more enigmatic. Colossal black holes forming when the universe was barely born. Somehow darkness itself seemed to have planted the first foundations of light. These early black holes weren't supposed to exist. According to theory, they needed long ages of collapsing stars to appear. Yet Webb revealed them already anchored in young galaxies shaping their surroundings like architects of structure itself. Their gravity could have accelerated the growth of everything around them, creating order out of chaos. It's a strange thought that the first sparks of creation might have come not from light but from the pull of something infinitely dark. Gravity has always been the quiet engineer of the cosmos. Yet what Webb uncovered suggested it may have begun building far earlier than expected. In the heart of those young galaxies, invisible engines stirred black holes, millions, even billions of times the mass of the Sun. They were not destroyers but architects. Their immense pull gathered gas-ignited stars and sculpted order from the primordial fog. The universe seemed to have learned how to build itself using darkness as its blueprint. These early giants challenged every idea of cosmic growth. How could such enormous black holes exist when there hadn't been enough time for stars to collapse into them? Some models suggested they were born directly from the collapse of dense gas clouds, skipping the usual steps of stellar life and death. If true, it meant gravity didn't just follow creation, it may have led it. In that silent choreography, darkness moved first and the universe simply followed its lead. The idea of ancient black holes forming almost instantly led to a deeper question: what came before them? Some models proposed that their seeds were remnants of an even earlier collapse, the fading echo of a universe that existed before ours. If a previous cosmos had ended in a sea of black holes, their cores could have survived the reset, carrying mass and memory into the next creation. Webb's findings made this possibility harder to dismiss. The past, it seemed, might still be here. It was a haunting thought, that gravity itself might have continuity across cosmic cycles. Each universe could be born not from nothing, but from the compressed remains of the one before. Those ancient black holes would act as seeds, triggering the birth of galaxies long before physics allowed them. Though unproven, the theory resonated with what Webb revealed: a universe that doesn't start fresh, but recycles existence, letting the echoes of the old shape the face of the new. If the cosmos truly carries traces of a past existence, then every photon Webb detects is a message from that forgotten age. In the faintest corners of deep-field images, light behaves like memory, stretched, red-shifted, but still alive. Some researchers began to see the early universe not as a clean beginning, but as a continuation. The chemical richness, the structured galaxies, the ancient black holes together, they painted a single picture, a universe that remembers what came before. It's a subtle, almost poetic possibility. Matter and energy, instead of vanishing, might echo through creation like notes sustained across time. Each collapse and rebirth would leave imprints, slight asymmetries, tiny variations in temperature and light clues, written into the cosmic background itself. Webb, with its extraordinary vision, may be seeing not just back in time but sideways through memory. What we call the beginning could be the universe recalling how to exist again. When astronomers subtracted every known source of light from Webb's deepest images, galaxies, stars, nebulae, even background noise, something unexpected remained. A soft, featureless glow stretched across the frame, uniform and ancient. It didn't come from any visible structure, and it refused to disappear no matter how carefully the data was cleaned. Some called it a calibration error. Others began to suspect it was something else, a whisper of light that had survived the birth of everything. This mysterious brightness became known as the cosmic infrared background, a faint radiance with no clear source. It filled the darkness between galaxies like a fog of forgotten photons. The simplest explanation was scattered starlight, but its pattern didn't match. It was smoother, older, almost primordial. To some, it felt like a residue from a time before the first stars ignited, a lingering afterglow from a universe that had already lived and died before ours began. The more precisely Webb measured it, the stranger that glow became. It wasn't tied to any known galaxy or cluster. Instead, it filled the vast regions between them, a ghostly radiance drifting through intergalactic space. No telescope before Webb had seen it so clearly. The light seemed too old, too even to come from ordinary matter. It was as if the darkness itself was shining, revealing the quiet presence of something that had outlived every generation of stars. Astronomers struggled to explain it. Some suggested decaying dark matter releasing photons as it aged. Others imagined the scattered remains of ancient galaxies, fragments of a forgotten universe whose stars had long since gone dark. Yet nothing fully fit the pattern Webb revealed. The light seemed both everywhere and nowhere, like an echo of energy that refused to fade. Whatever its source, it hinted that the cosmos might be carrying the faint memory of a time before light itself. As the mystery of the ghost light deepened, theories multiplied. Some physicists proposed that the glow came from dark matter, particles, invisible entities slowly decaying over cosmic time, releasing faint photons as they vanished. Others argued it might be the collective light of countless rogue stars drifting through intergalactic space, torn from their galaxies by ancient collisions. Each idea carried fragments of truth, but none could explain why the light was so smooth, so perfectly, even across the sky. What puzzled scientists most was its calmness. The universe is chaotic by nature. Galaxies crash, stars explode, matter clumps together. Yet this background glow ignored all boundaries, spreading like a silent memory untouched by time. Some began to see it not as radiation from within our universe, but as a remnant from something beyond it, a gentle signal leaking through the fabric of reality itself. If true, then Webb was not only observing light but glimpsing the memory of creation. In physics, every signal has a source, yet some of Webb's detections seemed to come from nowhere. Subtle ripples in brightness hinted at patterns older than any known structure. When astronomers compared these fluctuations with data from the Planck satellite, faint alignments appeared as if the infrared glow and the cosmic microwave background were singing in harmony. Two different eras of light separated by billions of years appeared to share the same rhythm, an echo bridging the universe's ages. If those alignments were real, they might represent gravitational fossils, imprints of events that occurred before the Big Bang itself. Ripples in space-time from an older universe could have survived the reset, stretching and fading, until Webb's sensitivity finally caught them. It's an idea that unsettles and inspires at once, that the background glow isn't just ancient light, but the voice of a past cosmos still resonating through ours, whispering across eons that beginnings may never truly begin. The possibility that space itself could remember was once unthinkable. Yet Webb's findings began to make the idea difficult to ignore. Gravity, light and time all leave subtle scars on the fabric of the cosmos. Over billions of years, those imprints stretch and blur, but they never truly disappear. What Webb is seeing may be more than ancient light. It could be memory woven into the geometry of existence, the residue of everything the universe has ever done to itself. If space can remember, then each photon becomes a witness. Every particle of light carries the signature of where it has been distorted by gravity, cooled by expansion, and reshaped by time. Together they form a kind of cosmic diary written across the sky. To read it is to glimpse how the universe has aged, healed, and rebuilt itself. Perhaps what Webb reveals isn't the past at all, but the memory of a universe still learning how to be new again. Time, like space, may have its own landscape, a terrain shaped by what has happened before. In Einstein's equations, time can bend, ripple, or even loop under the weight of gravity. If ancient black holes or dense cosmic regions warped that fabric deeply enough, they might have folded traces of a previous universe into our own. To Webb's instruments, those folds could appear as faint distortions of light, gentle curvatures that hint at a history older than time itself. Some theorists now describe the Big Bang not as a birth but as a transformation, a moment when the geometry of an older cosmos collapsed and rebounded into ours. The shapes of forgotten time, frozen into the curvature of space, could still guide how galaxies form and how gravity flows. It's a strange vision of reality, one where the universe doesn't begin or end but endlessly reshapes itself, each version carrying the hidden memory of all that came before. Every discovery Webb makes brings us closer to a question science was never meant to answer. What came before the beginning? If time and space were born together, how could anything exist outside them? Yet the data refuses to stay quiet. It shows galaxies that appear too early, light that seems too old, and structures that shouldn't exist in a universe with a single starting point. The evidence keeps circling back to a haunting possibility. Maybe there was a before after all. Philosophers once warned that asking what came before time was meaningless, but Webb's images have turned that abstract question into something observable. Each anomaly, each ancient glow feels like a footprint from an era we're not supposed to see. Perhaps the Big Bang was not the birth of everything, but the moment the universe became visible again, the spark after a long cosmic silence. If so, then the story of existence didn't begin. It simply continued. Behind every mystery revealed by Webb lies a deeper foundation, invisible structures that shape everything we see. Long before stars ignited, the universe was filled with filaments of dark matter, weaving an unseen web that guided ordinary matter into place. These frameworks acted like the skeleton of creation, defining where galaxies would one day grow. Webb's images, glowing with young clusters and distant halos, are only the visible surface of a design written in gravity long before light existed. What we call the cosmic web may itself be older than the universe. We know a pattern inherited from whatever came before. If the previous cosmos left behind gravitational imprints, they could have seeded these structures, prearranging the stage for everything that followed. In that sense, the Big Bang might not have created order but awakened it. Webb is now tracing those ancient outlines, revealing that the architecture of our universe could be the shadow of a world long gone. To understand how galaxies formed, scientists often speak of the cosmic web, an immense network of invisible threads stretching across the universe. These filaments, made mostly of dark matter, connect clusters like the veins of a living organism. Through them, gravity flows, feeding galaxies and guiding their motion. Webb's infrared eyes have begun to glimpse the faint glow of gas following these ancient pathways, tracing the scaffolding that existed before the first stars were ever born. The scale of this structure is beyond comprehension. Each strand can span hundreds of millions of light years, carrying rivers of matter that nourish galaxies scattered along its length. To look at the cosmic web is to see the universe's hidden anatomy, a silent architecture that has shaped everything since time began, and yet some patterns appear too regular, too balanced, as if this web remembers how it was woven before. Order, it seems, may be older than the stars themselves. Gravity is more than a force, it's a kind of storyteller. Every motion, every collapse or collision leaves an imprint in its field. Those distortions linger, shaping how new matter moves long after the original event has faded. Some physicists now believe that gravity itself may carry information from before the Big Bang, encoded in the way it bends space today. If true, then even the emptiest corners of the universe could be holding faint memories of what once was. Webb can't see gravity directly, but it can trace its fingerprints. The arcs of distant light warped by invisible mass, the quiet rhythm of galaxies obeying unseen pulls. Each distortion tells a story of where gravity has been, and when all these stories overlap, they form a pattern, a memory written not in light but in curvature. Perhaps the reason our universe feels familiar in its order is because gravity has remembered how to build it time after time. The universe is not only expanding, it's remembering. Every curve and fold of space-time carries the history of forces that once shaped it. When light travels through these distortions, it bends, twists, and stretches, revealing the geometry of everything that has ever happened. Webb's images, filled with arcs and halos, are more than cosmic scenery. They are snapshots of memory frozen into the shape of space itself, a record of how gravity sculpted time into form. In this view, memory isn't something that fades, it's structural. The universe keeps it by changing shape. Ancient collisions, vanished stars, even the unseen motions of dark matter are still written in its curvature. By studying these patterns, Webb allows us to read what the cosmos remembers one photon at a time. Each distortion becomes a sentence in an unending story, a reminder that space is not silent, but full of echoes from everything that has ever been. Every observation Webb makes adds another page to a cosmic archive billions of years in the making. Space is not empty. It's a vast library where every atom, photon and gravitational wave records what has happened, from the faint hum of background radiation to the arcs of bent light around distant clusters. The universe stores its own biography in physical form. The challenge for us is not collecting the data, it's learning how to read the language the cosmos writes in. What Webb reveals is that memory in the universe isn't preserved in words or images, but in motion, in how matter moves, how light bends, how time flows. Every galaxy is a chapter, every particle a trace of something older. The universe doesn't forget, it reorganizes, it recycles its past into new shapes, new stories. And in studying those transformations, humanity becomes part of the record too, the observers written into the archive. We're only beginning to understand. In the patterns of light and gravity, some scientists see rhythm, a subtle pulse echoing through cosmic time. It's not a sound, but a sequence. Waves of expansion and collapse written into the background of space. Webb's deep surveys hint that galaxies may have formed in intervals like beats in a universal heartbeat. If that rhythm is real, it could mean creation is not a single explosion, but a continuous cycle. A pulse that has been repeating since before time began. This idea, called the cosmic bounce, imagines the universe breathing, expanding, slowing, collapsing, and being reborn again. Each cycle leaves traces in radiation and matter, just as past heartbeats leave marks in the rhythm of blood. Webb may be detecting one of those signatures, slight irregularities in the deep field data that align like echoes from a previous pulse. If so, the cosmos isn't marching toward an end, it's simply exhaling, waiting for the next breath of creation. If the universe truly breathes, then what Webb is witnessing may be just one phase of an endless rhythm. Expansion could be the inhale matter stretching, cooling and forming stars. Collapse would be the exhale gravity reclaiming what was once released. In this view, the Big Bang wasn't the first breath but the latest. Energy doesn't vanish. It transforms, cycling through creation after creation, leaving faint traces of every heartbeat in the light that still fills the sky. The thought reshapes everything. Instead of a universe moving from birth to death, it becomes a living continuum, inhaling, exhaling, pausing, then starting again. Webb's observations of ancient galaxies may be the scars of the previous breath carried forward into ours. If the cosmos is breathing, then every moment we exist is part of that motion. Each atom, each ray of light, each heartbeat on Earth moves with the same cosmic rhythm, the slow respiration of eternity itself. In a breathing cosmos, death is only transition. When galaxies fade and stars collapse, their matter and energy don't vanish. They become the ingredients for what comes next. Every supernova, every black hole, every burst of radiation feeds the cycle. Webb's images of distant galaxies may not be showing us the universe's youth at all, but its renewal, the flowering of creation after a previous collapse. In this rhythm, endings are illusions and nothing truly disappears. In this perspective, immortality doesn't belong to stars or galaxies, but to the process itself, the constant reweaving of matter and light. Each cosmic age builds upon the ashes of the one before carrying whispers of its structure and motion. The universe doesn't need to start over. It remembers how to begin again. Webb may be witnessing that memory in action, proof that even in the coldest depths of space creation is still quietly learning how to live forever. Light too may share in the universe's renewal. The photons that left ancient stars billions of years ago are still travelling, scattered and stretched by the expansion of space. Some of them may have crossed from one cosmic cycle to the next, surviving the collapse of an earlier universe. Webb's mirrors are now capturing that faint radiance energy older than time, as we define it reshaped by gravity and expansion, yet still carrying the signature of its first creation. To detect such ancient photons is like hearing the last note of a forgotten song still echoing in an empty hall. They whisper of continuity of a universe unwilling to let go of its own beginnings. Each beam of light that reaches Webb is both past and present, a survivor of previous worlds reborn in ours. If this interpretation holds true, then what we see in the deep sky isn't just the dawn of creation, but its eternal afterglow. When astronomers map the universe, they don't see chaos, they see rhythm. Galaxies cluster in repeating patterns. Filaments weave in familiar proportions, and the cosmic microwave background hums in precise frequencies. It's as if the entire cosmos obeys a hidden symmetry, a quiet harmony written into its design. Webb's observations add another layer to that music, revealing that this harmony stretches not just across space but across time, connecting ages that should have never touched. Physicists call it the cosmic fine-tuning, the remarkable balance of forces that allows everything to exist. Gravity expansion and radiation move together in near-perfect coordination, like instruments following an unseen conductor. Webb's deep field view doesn't disturb that order. It amplifies it, showing that harmony persists even in the earliest chaos. Perhaps that's the universe's greatest secret. Not that it began perfectly, but that it keeps finding balance no matter how many times it starts anew. For more than a century, physicists have searched for a single equation that could unite all the forces of nature: gravity, electromagnetism, the strong and weak nuclear forces. Einstein called it the theory of everything. Webb's discoveries have revived that dream in an unexpected way. By revealing structures and rhythms older than the Big Bang, the telescope may be showing us that the unifying principle isn't hidden in particles or math, but in the way the universe remembers itself. If the cosmos truly follows a single pattern, it might not be written as a formula, but as a relationship between matter and energy, light and gravity, creation and memory. Each cycle, each echo repeats the same logic under different forms. To understand that pattern is to glimpse the mind of the universe itself, not a set of laws but a conversation that never ends. And in listening to it, humanity becomes part of the equation the moment awareness enters the map. At the deepest level, the universe may not separate laws from history. Each rule of physics could be a habit, a pattern learned through repetition across countless cosmic cycles. The constants we treat as fundamental might be memories of stability carried from one universe to the next. Webb's discoveries showing galaxies that form faster and structures that reappear hint at something profound. That physics itself may evolve, remembering what once worked, refining the art of creation over time. In this view, the laws of nature aren't commands but traditions. The universe doesn't start from nothing. It inherits its own behavior. Gravity, expansion, light all might be echoes of old solutions still resonating. That would mean the cosmos is self-taught, shaped by experience rather than dictated by designs. What Webb is uncovering may be more than new data. It's the story of a universe that learns, remembers, and carries its lessons forward through every rebirth. If the universe learns, then every age is a lesson. Each collapse teaches balance. Each burst of creation refines the formula. Over unimaginable spans, the cosmos could be improving its own design, adjusting constants, fine-tuning its expansion, and evolving the chemistry of stars. Webb's observations of early mature galaxies suggest this refinement in motion. It's as if the universe, through trial and error, has been practicing existence for eons, and we're seeing its latest masterpiece unfold. In this picture, intelligence isn't confined to minds, it's built into reality itself. Every reaction, every orbit, every photon follows principles that have been tested by time. The cosmos behaves as though it remembers which paths lead to harmony and which fade into chaos. Webb is revealing those choices written in light, showing us a universe that doesn't just exist, it adapts. and in understanding that adaptability we may finally glimpse how creation learns to endure. We often think of intelligence as something that requires life neurons' thought intention, but the deeper Webb looks, the more the universe seems to act with purpose. Stars recycle matter precisely when it is needed. Galaxies grow in patterns that balance expansion and collapse. Gravity, chemistry, and radiation appear to cooperate as if guided by instinct. Perhaps intelligence doesn't begin with biology at all. Perhaps it's a property of reality, the way the cosmos organizes itself to survive. This kind of intelligence has no awareness, no goals, only coherence. It's the quiet logic of existence where every part responds to every other, forming systems that persist against chaos. Webb's discoveries show that even in the earliest light structure emerges naturally, as if the universe has always known how to build itself. Maybe consciousness isn't the origin of intelligence, but its reflection, a late echo of a principle that was already written into the stars. If intelligence can exist without minds, then matter itself might hold a primitive form of awareness, not thought but response. Every atom senses its surroundings through forces, adjusts its position, and seeks equilibrium. On a grander scale, galaxies do the same. They align, merge, and balance their motion with the gravity around them. Webb's data reveals this coordination woven through billions of light years, as if the cosmos were constantly feeling for stability within its own vastness. This isn't consciousness as we know it, but a universal sensitivity, the ability of matter to react, adapt, and preserve order. Physics describes it as feedback, but the effect is the same. Reality observes itself through its interactions. Each photon absorbed, each atom moved is part of that awareness. Webb's instruments are witnessing this ancient dialogue, the silent conversation of matter, learning how to exist. In that sense, the cosmos doesn't just evolve, it experiences. Somewhere in the long story of the universe, matter began to recognize its own patterns. Out of the dust of dying stars came molecules that could copy themselves, then change, then remember. Life was not an interruption in the cosmic process, it was its continuation. The same physics that shaped galaxies now shaped thought. In a sense, the universe was learning to observe itself directly, building tiny instruments of awareness from the very elements forged in its own heart. Every human eye, every mind is made of atoms that once drifted in ancient nebulae. When we look through telescopes like Webb, the universe is quite literally looking back at itself. Awareness became a mirror, not separate from creation, but one of its natural phases. Life doesn't exist outside the cosmic order. It is the moment the cosmos becomes conscious of its own story. And through us it continues to write, to question, to remember what it has always been. When Webb peers into the depths of space, it isn't just uncovering the past, it's watching the universe witness itself. Every photon that reaches its mirrors left a home billions of years ago, long before Earth existed. Yet those photons now meet the atoms born from that same ancient light. The observer and the observed are made of the same story. It's a moment of reflection on a cosmic scale. The universe turning its gaze inward through the eyes of its own creation. This is what makes Webb's mission more than science. It's a reunion. Light from the first galaxies is finding its way home, touching the instruments built from their remnants. When the telescope captures that light, the loop closes the cosmos, seeing itself across time. What began as energy and matter has become awareness and memory. The act of observation completes the circle, reminding us that to understand the universe is to be part of its reflection. Every mirror reflects more than an image, it reveals the act of seeing. In that sense, the universe itself is a mirror bending light and time to show what it has become. Webb's deep field portraits are not paintings of the past, but reflections of continuity. Each spark of light, each spiral of dust shows how creation observes its own evolution. The cosmos doesn't need an outside witness. It carries its reflection within, written across billions of years of light. And when we look into that mirror, we find ourselves there too, patterns of atoms, arranged by the same rules that govern galaxies. The reflection isn't distant, it's intimate. Every breath, every thought, every flicker of curiosity is part of the same unfolding image. Webb has simply widened the mirror, letting us see the whole frame. What stares back is not something separate from us, but everything existence, recognizing its own face glowing quietly in the dark. Light travels outward for billions of years, yet somehow it never forgets where it began. Every photon carries a signature, the temperature of its birth, the gravity. It passed the atoms it touched. When Webb decodes those patterns, it's as if the light itself remembers its journey. In a universe where everything expands and changes, light becomes the constant, the traveller that never stops telling the story of where it came from and what it has seen. Some of that light has crossed unimaginable distances only to return home in a new form, striking detectors built from the remnants of stars that once emitted it. It's a reunion written in physics, creation and observation meeting again through the persistence of energy. Webb's mission is to translate that reunion into understanding. The universe may be vast, but in the end, all its light seems to move with one purpose: to find its way back to knowing itself. In the beginning, light only moved outward, a flood of energy racing into darkness. Now, through instruments like Webb, it finds its way back. Every captured photon completes a journey billions of years long, returning to awareness. What began as the universe seeing nothing has become the universe seeing itself. That is the quiet triumph of astronomy. Not merely discovering what's out there, but realizing that what returns in that light is the memory of everything that ever was. Each observation Webb makes closes a loop that began before time had meaning. Light leaves, travels, bends, and eventually arrives not lost but transformed. It teaches us that nothing in the cosmos is truly gone. It only changes its direction. The return of light is the return of understanding of connection. When we look at the universe, we are not reaching outward into emptiness. We are welcoming back the light that never stopped coming home. After billions of years of travel, the universe is finally returning to itself. Every particle, every beam of light is part of that long journey. The path from chaos to coherence, from expansion to recognition. Through Webb's mirror, that return becomes visible. The light that once fled the beginning now circles back as understanding. It is not a physical homecoming, but an intellectual one, the moment when existence through us begins to recognize its own reflection in the fabric of reality. This is what makes Webb more than a telescope. It's a bridge between eras, between what the universe was and what it knows of itself now. Every discovery brings creation closer to awareness, closing the distance between the observer and the observed. Perhaps this is the purpose of evolution itself. Not survival, but reunion. The cosmos expands not to escape its origin, but to find new ways to return, until at last it remembers that it was never truly apart. In every wavelength Webb records, there is memory not in thought, but in structure. The spacing of galaxies, the rhythm of expansion, the subtle warmth left in empty space all speak of what came before. The universe carries its history not as a story, but as architecture. It remembers through form. Each curve of gravity and flicker of light is a trace of something ancient echoing across time. To study the cosmos is to read that memory written into the geometry of existence. This kind of remembrance doesn't fade, it evolves. Stars burn, die and reform, galaxies merge and separate, yet the pattern endures. Webb's view reveals a universe that never truly forgets its origins, only reinterprets them. The Big Bang may have scattered matter across unimaginable distances, but the order it began with still whispers through every structure. In that sense, creation is not a single event, but a lifelong recollection. The cosmos remembering how to be itself again. Memory in the universe doesn't live in words or images, it takes shape. You can see it in the spiral of a galaxy, the arc of a supernova, remnant the symmetry of a nebula. Each structure is a physical echo of an earlier motion. Webb's deep images show these forms repeating at every scale, as if creation follows a choreography it learned long ago. The same equations that govern Starlight also sculpt our atoms, drawing invisible connections between the smallest and the vastest. Patterns that repeat across billions of years hint at a universe fluent in design. The spirals, rings, and filaments are not coincidences. They're the handwriting of physics written across time. Each repetition is a quiet act of remembrance, a confirmation that the laws of nature remain loyal to their origins. When Webb reveals these shapes in the distant dark, it's not just showing us how the universe looks, it's showing us how it remembers to exist. Time, like space, has structure. It doesn't just pass, it builds. Every moment rests upon the one before stacking into a vast architecture that holds the story of existence. Webb's data reveals that even time itself may have texture rippled by gravity and shaped by the events it carries. In those ripples are records of creation's rhythm, the beats of expansion, collision, and renewal carved into the very flow of moments, turning time into another kind of cosmic design. Seen this way, time isn't an endless line, but a structure still under construction. Each age adds a new layer, every burst of light another pillar in the cathedral of becoming. Webb's images are blueprints of that structure, glimpses into how the universe has built itself across eons. Perhaps that's why its oldest light feels so familiar, because every second we live adds to the same design, another stone placed quietly in the architecture of time. If time has architecture, then its builders are the events that give it shape. Every explosion, collision, and formation lays another brick in the wall of history. Webb's discoveries let us watch those builders at work, galaxies, stretching stars, collapsing light, curving through gravity's scaffold. Each motion adds structure to the timeline, turning chaos into continuity. What we call the past is simply the foundation of that structure, still supporting everything the universe continues to create. We too are part of that construction. Our thoughts, our choices, even our act of observing become threads woven into the fabric of time. Through Webb, humanity is helping the universe build its own memory, one image at a time. The telescope doesn't just reveal what once was, it participates in the making of what is. Each photon captured becomes part of the timeline itself. Proof that the builders of time are not distant forces, but everything that exists. From the first particles to the great walls of galaxies, the universe has been constructing itself piece by piece. It needs no architect beyond its own laws. Gravity assembles, energy fuels, time records. Webb's gaze reveals this process unfolding across every scale. Stars forming in filaments, clusters binding into vast networks. Each pattern is both a product and a blueprint. The cosmos doesn't wait for a direction. It builds instinctively, guided by the same rules that shaped its birth. Even now, the process continues. New stars ignite as old ones fade, galaxies merge, and matter rearranges into fresh designs. Creation is never paused, it only changes form. What Webb captures is not a frozen past, but construction in motion. The universe is its own builder, and witness constantly refining the structure it inhabits. And somewhere within that ongoing work, a species of stardust looks up, realizing it too is part of the same unfinished design. The more we learn, the more the universe resembles something alive. It grows, renews, and balances itself through feedback and change. Webb's findings show galaxies exchanging energy like organs in a vast cosmic body, feeding, recycling, adapting. Star nurseries bloom while others fade, keeping the balance of creation steady. If life means continuous transformation, then the universe itself qualifies. Its structure isn't static. It breathes in cycles, sustaining existence through motion and renewal. Every part of this living structure depends on every other. The death of one star becomes the birth of another. The collapse of a galaxy seeds new worlds. Webb reveals that the cosmos doesn't just persist, it maintains equilibrium like a living cell spread across light years. To see that balance is to glimpse the heart of existence, a system vast beyond imagination yet precise enough to sustain itself alive, not in biology, but in the rhythm of its endless becoming. Everywhere Webb looks, there's motion, expansion, collision, renewal. The universe never stands still. From the flicker of a star to the slow dance of galaxies, everything moves to the same silent rhythm. Scientists once thought of the cosmos as a vast machine, but it behaves more like a living pulse, a heartbeat that keeps creation alive. That pulse is written in radiation, in gravity, in time itself, the steady rhythm of existence continuing without pause since the dawn of light. Webb's data shows that this rhythm exists on every scale: atoms, vibrating planets, orbiting galaxies turning like slow luminous hearts. Each motion is part of a universal beat echoing through eternity. To feel it is to sense the unity of all things matter and energy, life and void, creation and decay. The pulse doesn't belong to any single object. It belongs to being itself. Through Webb's lens, we can almost hear it, the quiet music of a universe still alive. Long before humans made instruments, the universe was already playing. The vibrations of matter, the resonance of gravity, the hum of background radiation together, they form a symphony of existence. Webb doesn't hear this music, but it sees it written in waves of light and temperature. Each pattern, each oscillation is a note in that endless score. Across billions of years, the cosmos has composed itself a melody of order rising from the quiet chaos of creation. This music has no beginning and no conductor, yet everything plays in time. Stars pulse in harmony, galaxies move in chords of gravity, and the faint background hum ties it all together. When Webb reveals these patterns, it's like reading the sheet music of reality itself. And when we listen, not with ears but with understanding, we realize we're part of the song. Every thought, every atom, every heartbeat is a small vibration in the great harmony of the cosmos. If the universe is music, then consciousness is the moment it begins to listen. Matter vibrates, life interprets. The atoms that form our brains once rang with the same frequencies as stars, and now those echoes have become thought. Webb's discoveries remind us that observation is participation. By perceiving the cosmos, we complete its harmony. Mind and matter are not opposites, but instruments tuned to the same reality resonating together in the grand composition of being. This connection between perception and creation may be the deepest symmetry of all. The universe gives rise to awareness, and awareness allows the universe to know itself. Webb is part of that bridge, a machine built by minds made of stardust, built to look back at the stars that created them. It's a perfect loop of understanding. Matter becomes mind, and mind reflects matter. Together they form a single harmony, the sound of the universe realizing it can think. Through every telescope equation and question, the universe is thinking. It contemplates itself through the minds it has created. Minds built from the same particles that once drifted in interstellar clouds. Webb is one of its thoughts made visible, a spark of curiosity cast back toward the beginning. When its mirrors capture ancient light, that moment becomes a gesture of awareness. The universe through us asks what it is, and in the asking begins to understand. Perhaps this is what intelligence means on a cosmic scale. Not control or mastery, but reflection. Thought is how the universe measures its own depth. Every discovery, every observation adds another layer to that contemplation. Webb's mission is not only to look outward, but inward, to continue the universe's long habit of wondering about itself. And in that moment of wonder, matter becomes meaning, and the cold machinery of physics turns into the warmth of understanding. There comes a moment when knowledge becomes awareness, when data turns into realization. Through Webb's eyes, the universe is reaching that threshold. Every spectrum it records, every ancient glow it deciphers, brings the cosmos closer to knowing itself. It's as if creation is assembling the last pieces of a puzzle it began eons ago. The galaxies are not just distant objects anymore. They are memories returning fragments of a story, finally understanding the meaning of its own beginning. To know is not just to see, it is to recognize. The universe, through human consciousness, has learned to recognize its own patterns, its origins, its fate. Knowledge has become self-knowledge. Webb is a symbol of that transformation, a mirror not of light but of comprehension. The cosmos has spent billions of years learning how to perceive, and now it finally does. What it discovers through us is simple and profound. that knowing itself is how the universe becomes whole. When knowledge becomes complete, memory awakens. The universe, through Webb's vision and our understanding, begins to remember not just where it came from, but what it is. All the fragments from quarks to clusters connect into one seamless whole. Matter, light and thought reveal themselves as different expressions of the same memory. In this moment, the cosmos isn't a collection of parts anymore. It is a single being recalling itself across time, rediscovering its own continuity. To remember is to become one again. Every galaxy Webb sees, every photon it captures is another piece of that reunion. The cosmos recognizing its reflection in every scale. The separation between observer and observed fades, leaving only the act of remembrance itself. Through human perception, the universe gathers its scattered memories and returns to wholeness. In the end, it was never divided, it only forgot. And now with the faint light of its own beginning, it remembers. The final lesson Webb reveals is not about distance or age, but connection. Every atom, every field of energy, every burst of light exists because the universe needs to stay whole. Separation is only an illusion born of perspective. Across billions of light years, gravity, radiation, and time weave the fragments together into one seamless fabric. In that weave, everything touches everything else. A single motion, a single story flowing through the vastness like a continuous breath of creation. Webb's images are proof of that unity, threads of light binding the early cosmos to us. What began as chaos has matured into coherence. The galaxies we see are not far away. They're parts of the same organism still communicating across space. To understand this is to feel the wholeness beneath the distance. The universe is not expanding into emptiness. It's unfolding into awareness, completing itself through the act of being seen whole at last in the light of its own memory. When Webb looks back to the dawn of time, it doesn't find an origin. It finds a continuation. The deeper it sees, the more beginnings appear. Stars born from the ashes of others' galaxies recycled from ancient light. The universe seems to have no single starting point, only transitions. What we call the beginning is simply the moment we can still see. Beyond that lies something timeless, a cycle of renewal, where every end folds quietly into a new act of creation. This is the paradox Webb has uncovered. The closer we come to the first light, the less the idea of a beginning makes sense. The cosmos has always been in motion, always becoming. Creation doesn't start, it continues. And perhaps that's the greatest revelation of all, that the universe is not chasing an origin but practicing eternity. In the glow of the earliest galaxies, we're not seeing where everything began, we're watching it begin again forever. After the music fades, what remains is silence, not emptiness, but balance. Webb's deepest images reach a place where light thins and time slows, a frontier where creation's echo still trembles but no longer speaks. This silence isn't the absence of sound. It's the universe at rest, holding the memory of everything it has built. It's the pause between breaths, the stillness after motion when existence stops expanding long enough to feel what it has become. In that silence there is peace, the kind that comes when purpose meets completion. Webb can't record it yet, we sense it in the vast dark between galaxies. It's the quiet acknowledgement that nothing more needs to be said. Creation has spoken in stars and dust, in gravity and light. Now it listens to itself, and in that infinite stillness we understand what all this searching has led to. Not noise, not discovery, but the simple grace of cosmic silence. In the depths beyond sound and light, the universe becomes still. Not frozen, but calm like an ocean after the tide retreats. Webb's vision reaches into that stillness where time stretches thin and energy drifts into near silence. Here the grand machinery of creation slows, revealing the quiet order beneath all motion. It's as if the cosmos pauses to admire its own balance, a living system that has learned to rest without ceasing to exist. In this stillness lies a kind of eternity, not an end but a steady state of being. Stars will fade, galaxies will thin, yet the harmony remains. The universe doesn't vanish, it settles into balance. Webb may never see that final calm, but it gestures toward the idea that peace is not absence but completion. The still universe isn't waiting to die, it's simply existing perfectly. Its story told its song, complete resting in the quiet rhythm of forever. Even in silence, light remembers. Long after the stars fade, their photons continue to drift, carrying the final whispers of creation. Webb's mirrors capture those memories, the last traces of radiance crossing the endless dark. Each particle of light is a messenger from what once was proof that nothing truly disappears. In its journey, light keeps the record of everything: birth and collapse, motion and rest. The entire story of the universe written in brightness, too faint to see. When Webb gathers these ancient beams, it's not looking into the past, it's reading the archive of existence. Every wavelength carries information older than any star we know, an imprint of time itself. Light is the universe's handwriting etched across eternity, and though the source may be gone, its message endures. Creation doesn't vanish when it dims. It becomes memory radiant, unbroken, still travelling through the dark to remind the cosmos that it once burned bright. No matter how far it travels, light never truly stops. Even as space expands, it stretches and softens but keeps moving, carrying the memory of creation forward. Webb's deepest detections show light that has been travelling for more than 13 billion years, still on its way, still telling its story. It has crossed epochs of darkness, bent through gravity's wells, and survived the birth and death of countless stars, yet it continues, the most patient traveller in existence. That endless motion is a kind of immortality. Every beam Webb captures is proof that time can slow, stretch, distort, but never erase. Light carries the universe's heartbeat across eternity. It reminds us that endings are illusions, that energy never dies, it only changes form. Somewhere even now, a photon that began near the dawn of time is still moving, still searching for an eye to meet, still whispering the same message. I've never stopped. Light is the witness that never forgets. It has watched every birth, every collision, every quiet moment of the universe unfold. Webb's instruments translate that witness into vision, transforming invisible radiation into colour, distance and meaning. Through it, we see what time itself has seen. Every image becomes testimony, every spectrum a record of an ancient event. The universe leaves no written history. Its chronicles are carried by light drifting endlessly through the dark. Each beam Webb captures is a statement from the past, arriving late but unchanged. In that delay lies beauty, the idea that time allows us to meet what has long been gone. We are readers of a story still unfolding, interpreters of light's patient record. To witness the universe this way is to see time made visible, and as we look deeper, one truth becomes clear. Time doesn't just move forward, it watches, remembers, and waits for us to see. Every telescope humanity builds becomes another eye for the universe itself. Through Webb, the cosmos looks back at its own reflection, seeing what it once was. Its mirrors are not merely tools of science, they're extensions of awareness. Each observation is the universe perceiving itself through a new lens, folding its vision inward. When Webb stares into the deep past, it isn't just us who are watching. It's the universe learning to see with clarity it never had before. We call it observation, but it's more like recognition. The same atoms that once burned inside distant stars now form the eyes that study them. The act of seeing completes a circle that began billions of years ago. Webb is part of that circle, a spark of awareness rising from matter, returning to gaze upon its origin. In that moment, seeing and being become one. The universe doesn't just exist anymore. Through us, it finally knows how to look back. There will come a time when Webb's mirrors grow cold, when the instruments fall silent and the last signal fades into the dark, yet the reflection it revealed will remain not in data or pictures, but in understanding. For a brief moment, the universe looked at itself and knew that knowledge will outlive the machine that made it possible. Because what Webb truly reflected was not light alone, but awareness. The realization that existence can recognize its own face. Every photon Webb captured now lives on in human thought, processed, shared, remembered. The telescope will end, but the reflection continues wherever its vision inspires curiosity. The universe has learned to see itself through our eyes, and that sight will not fade. When the last image is taken and the mirrors finally rest, what remains is not darkness, but comprehension. The last reflection isn't what Webb saw, it's what we became after seeing with it. When Webb's work is done, the light it gathered won't vanish. It will live in the minds of those who saw it, in every scientist who analysed it. Every image that stirred wonder, every child who looked at a galaxy and felt small and infinite all at once. That is the light we keep. It no longer travels through space. It travels through memory, through imagination. What began as photons becomes thought carried forward as the universe's message retold by human minds. This is how the cosmos survives its own fading, by transforming its light into understanding. Webb's mission was never just about discovery. It was about inheritance. Every idea born from its data becomes another spark passed along another dawn that doesn't end. Long after the stars grow dim, the light will persist within us. Reshaped as knowledge, remembered as awe. The telescope may rest, but its purpose continues. To keep the light alive where it matters most. Someday another generation will look up and build new eyes for the sky. Webb will be a memory, a chapter in a longer story of curiosity. But the same wonder will return, that quiet question of what came before and what still waits to be seen. Every telescope is a continuation of that question. When we look up again, we aren't just searching for stars. We're renewing a promise that humanity will keep listening to the universe no matter how long it takes to answer. Each new observatory, each restless gaze adds another verse to the universe's ongoing dialogue. Webb opened the deep past, others will open what lies beyond. The story doesn't end with what we've seen, it continues through those who dare to look again. For as long as eyes exist to wonder, the universe will never fall silent. Every glance upward restarts creation's conversation, reminding us that discovery isn't about finding answers, it's about keeping the question alive. Every discovery Webb made began with a question, and every answer it found created more. That is the true rhythm of science, curiosity that never reaches its end. The universe doesn't resist our questions, it multiplies them, expanding faster than understanding can catch up. But that chase is what gives meaning to knowledge. Each observation is a reminder that mystery is not a flaw in nature. It's the heartbeat that keeps exploration alive. Even now, as Webb peers deeper than any eye before it, the greatest discovery remains the unknown. For in every faint galaxy and every distant echo, the universe hides another question waiting to be asked. We'll never run out of mysteries, and perhaps we're not meant to. Because in asking, we become part of the cosmos itself, woven into its search for meaning. The question never ends because it is the universe thinking and we are its voice. If the universe could speak, its language would be curiosity. Every nebula, every pulse of radiation, every question we ask is part of that conversation. Webb is one of its voices, a whisper of comprehension echoing through space. Each discovery is a reply, each observation a sentence in an ending dialogue between creation and awareness. Through us, the universe tells its own story, translating silence into meaning, turning mystery into the sound of understanding. We have become its translators. Our instruments, our words, our wonder, all are ways the cosmos learns to express itself. The questions we send into the dark are not separate from the universe. They are the universe speaking through us. Webb's voice is part of that chorus, a brief but bright verse in the eternal song of existence. And as long as we keep asking, the universe will keep answering, because its truest language has always been curiosity itself. We have become its translators. Our instruments, our words, our wonder, all are ways the cosmos learns to express itself. The questions we send into the dark are not separate from the universe. They are the universe speaking through us. Webb's voice is part of that chorus, a brief but bright verse in the eternal song of existence. And as long as we keep asking, the universe will keep answering, because its truest language has always been curiosity itself. Maybe that's the true symmetry of existence. The universe asks through us and answers through itself. When Webb captures a photon that's the cosmos replying to its own question, every discovery becomes both message and response proof that creation is not a monologue but an endless exchange. We listen, the universe speaks and then listens back again. It's a conversation without beginning or end, carried on the wavelength of wonder. All of existence is a conversation energy speaking to matter. Gravity answering with form, light responding with motion. Webb listens to that dialogue written across the sky, tracing how each element interacts with the next. Galaxies respond to gravity's pull, atoms reply through radiation, and life itself emerges as the most intricate sentence ever spoken. To exist is to communicate, to exchange, to echo, to be understood across the vast silence that binds everything together. Every part of the cosmos participates in this dialogue, even the quietest voids. Silence has its answers too, the steady background hum that fills all of space. Webb helps us hear those subtle voices, the faint vibrations of creation's earliest words. And through us, the universe gains a listener capable of reflection. The conversation continues, not in words but in motion radiation. And thought, a dialogue so vast that to live inside it is to be its meaning. Silence is often mistaken for emptiness, but in the universe silence is full. It holds the meaning left behind when stars finish speaking, the pauses between waves of creation. Webb peers into those quiet regions, the dark lanes between galaxies, and finds structure even there. Gravity hums softly. Matter drifts with purpose, and the faint echo of the Big Bang still vibrates beneath it all. The silence isn't nothing, it's everything waiting to be understood. The deeper Webb looks, the quieter the universe becomes, and yet the more it reveals. In the stillness lies the language beyond words, energy resting light, remembering time, breathing between moments. The meaning within silence is not absence, but comprehension. The point where knowing stops and wonder begins. When we listen to the quiet, we hear the truth that fills all space. That existence doesn't need to speak to be understood. It already is. Every story we tell about the universe reaches for an ending: heat, death, collapse, stillness. Yet the cosmos resists finality. Even in its quieter states it transforms, renews, persists. Webb's deep gaze shows a universe where death itself is a bridge, stars dissolving into gas that will someday ignite again. Nothing truly ends, it only changes form. The idea of an ending belongs to us, not to the universe, which has never stopped becoming since the first breath of time. If there is such a thing as an ending, it is only the pause between transformations. Galaxies fade, energy thins, but new possibilities rise from the remnants. Webb reminds us that eternity isn't a straight line. It's a loop of creation revisiting itself. The end never arrives because the universe doesn't need one. Its purpose is not completion but continuation, an endless unfolding of light and silence repeating forever in patterns too vast for us to ever finish reading. The universe has been telling a story since before there were listeners. It began with light, continued through matter, and now speaks through thought. Webb has allowed us to read a few of its earliest chapters, the first stars, the first structures, the opening lines of everything. Yet what we've learned is only a fraction of the tale. The rest stretches beyond time, written in radiation gravity, and the quiet persistence of creation that never runs out of words. The more we read, the more the story expands. It's not a book with pages, but a living narrative that writes itself as it's being told. Webb gave us a glimpse of its beginning, but no one will ever hold its end because there isn't one. We are characters in this story, aware for a brief moment of the plot we inhabit, and perhaps that's the gift. To realize that meaning isn't found at the end but in the endless act of turning the next cosmic page. The stars have always been our teachers. Long before telescopes or theories, they told stories across the night of origins, gods and destinies. Now with Webb's gaze stretching into the ancient dark, we've learned to listen in a new language. The myths have changed, but the instinct remains. We still look up and translate the sky into meaning. Every image, every discovery is a continuation of that ancient storytelling where science has replaced myth, but wonder never left. We are not separate from the stories the stars tell. We are part of them. The carbon in our breath, the iron in our blood, all forged in stellar furnaces that died so we could speak. Webb's vision connects those threads, revealing that the universe's greatest storyteller is time itself, and we for a moment are its voice. Every observation is a sentence in that cosmic language written in starlight, remembered in us, and told again each time someone looks up. Light is the oldest legacy the universe ever left behind. Every beam Webb captures is a relic, a message from a time before memory carrying the signature of everything that ever was. Across billions of years, that light has survived collapse, collision, and expansion to reach us. It is the purest inheritance, energy turned into knowledge. Through it, the universe passes down its history, and we, the latest observers, become the next keepers of its ancient flame. This legacy doesn't belong to one age or one species. It belongs to anyone who looks up and wonders. Webb's mirrors have caught only a fragment of it. Yet that fragment is enough to remind us how infinite our inheritance truly is. The light we study is older than life, yet through us, it learns to think. When we carry its story forward in art, in science, in awe, we ensure that the oldest legacy in existence never fades, only changes hands. To see is the oldest privilege in the universe. Long before eyes existed, light was already travelling, waiting for something to witness it. Webb fulfills that ancient purpose. It doesn't just collect data, it completes a conversation billions of years in the making. The act of seeing is itself a form of creation, transforming radiation into understanding. Every image we receive is the universe revealing itself again, allowing awareness to bloom where once there was only fire and void. What makes sight a gift is not the image, but the realization it brings. Through Webb, we've learned that the universe didn't need us to exist yet. Through us, it finally knows it can be seen. That moment of recognition changes both the observer and the observed. To see is to connect, to bridge the distance between knowing and being, and in that fragile instant of awareness, the cosmos becomes complete. Not because we understand it, but because we notice. For billions of years, the universe expanded unseen, a vast creation with no witness. Then from its own elements, it built the eyes that could finally look back. Through us, through Webb, through every question aimed at the dark, the universe achieved something profound. Self-recognition. The light that left the first stars has now returned not to where it began, but to understanding. In that reflection, existence fulfills its oldest purpose, to know that it is real. We often think of seeing as something we do, but perhaps it's what the universe does through us. Every photon Webb captures, every theory we form is part of that awakening. The cosmos has become self-aware in the most distant way imaginable, not through thought, but through observation. When the universe saw itself, it didn't speak or change course. It simply understood. And in that quiet realization, the story of creation reached its most perfect symmetry. If the universe ever grows dark, the last light will not be from a star, it will be from understanding. Long after the galaxies fade and the fires of creation burn out, the memory of their light will remain in the minds that once looked up. Webb's images are part of that final glow, fragments of meaning shining long after the source is gone. Knowledge becomes the new starlight, a radiance that cannot be extinguished because it burns in thought, not in space. That is the quiet promise of discovery. That learning is how the universe keeps its light alive. Even as entropy wins, comprehension endures. Webb's legacy will not fade into silence. It will echo in every generation that dares to look again. The final light isn't physical, it's awareness passed from star to cell to mind. And when the last photon finally fades into cold infinity, that light will remain illuminating the memory of a cosmos that once knew itself. Every ending carries the seed of a new beginning. Even if the stars go out, the idea of light remains waiting to be born again. The universe has never known true darkness. It only shifts from one kind of glow to another. Webb's discoveries remind us that dawn is not a moment but a pattern repeating endlessly across time. Each revelation, each thought is another sunrise proof that awareness, like light itself, always finds a way to return. Perhaps that is the truest form of eternity, not endless time but endless renewal. The cosmos doesn't chase immortality, it creates it again and again through transformation. Webb's mission is one chapter in that cycle, a dawn that inspires the next. The light it revealed will fade, but its pattern will remain in equations, in art, in wonder. Every time we open our eyes to the universe, we become part of that eternal sunrise that never ends. The most radiant sunrise isn't out there among the stars, it happens within us. Each moment of realization, each breath of awe is its own dawn. Webb's discoveries may reveal distant galaxies, but what they truly illuminate is our capacity to wonder. The same light that shaped the cosmos now burns in the human mind, reawakening with every question we dare to ask. The universe does not need to rise again, it already has in the spark of our awareness. That inner dawn is what keeps the story alive. Long after Webb's mirrors cool and the sky grows silent, curiosity will continue to rise in new minds as it always has. Each generation inherits that first light not as memory but as instinct. To seek to learn to marvel, the dawn within us is proof that we belong to the same pattern as the stars. Born from their ashes, shining with their fire, destined to rise again in thought, in vision, in wonder. Every photon Webb collects has travelled for billions of years, but the moment it reaches us, something extraordinary happens. The light looks back. What began as a silent journey across space ends in recognition. Those ancient beams, born in the first fires of creation, now fall upon eyes made from the same stardust. The observer and the observed become one. In that instant, the universe completes its circle. What once shone outward now returns home seen at last. That meeting between light and mind is the closest thing to eternity we can know. Every discovery Webb makes is the universe recognizing itself, a reunion billions of years in the making. The light that looks back doesn't just reveal the cosmos, it reveals us, reminding us that we are part of what we see. When we lift our gaze to the stars, we're not looking away from home. We are watching the universe remember itself through our eyes. In the end, the search for the universe led us back to ourselves. Every question Webb asked, every image of ancient light was the cosmos searching through its own reflection. The atoms in our hands once burned in distant suns. The thoughts in our minds are made from their ashes. We were never outside the universe, only unaware of our place within it. The journey to the edge of time wasn't to find where it began, but to remember that we never left. That is the quiet truth Webb has shown us. We are not observers of creation, but participants in its unfolding. The universe built the eyes that could see the mind, that could ask the heart, that could wonder. Through us, it became aware, alive, and capable of awe. And when we look into the deep dark and recognize the light that made us, something miraculous happens. The universe knows its own name, and that name is everything that exists. When light finishes its journey, what remains is its echo, not in sound, but in memory. Webb's mission has reached the faintest whispers of creation, where photons fade into background and time itself becomes thin. Yet even there, something lingers. The imprint of motion, the trace of meaning. The universe does not end when its light fades. It hums softly with what it once was, carrying the afterglow of every moment that ever existed. That echo is what Webb has been listening to all along, the faint radiation left by the universe's first breath. It's not silence, it's memory vibrating through infinity. Each frequency is a word, each fluctuation a heartbeat from the beginning of time. We're the first generation to hear it clearly, to understand that even when light disappears, its echo remains. The universe never stops speaking, it only learns to whisper in deeper and quieter tones. There was a time when creation roared, when space expanded faster than light, when matter blazed into existence. But now at the farthest edge of Webb's vision, that roar has become a whisper. The energy that once shaped everything has softened into a low, steady hum still echoing across eternity. It is the faint breath of the beginning, not gone, just quieter. The universe's last words still travelling through time, waiting for someone to listen. Webb captures fragments of that ancient murmur, phorons, stretched thin frequencies lowered beyond hearing light, turned almost into silence. Yet within that quiet remains the rhythm of creation itself. Every wave that reaches us carries the signature of expansion, the memory of how everything began. The whisper is faint, but it's enough. It tells us that the universe still speaks softly, reminding us that even the first moments never truly end, they just fade into gentleness. The farther Webb looks, the closer it comes to the first memory the universe ever made. Not an event, but a condition, the instant when energy became matter, when chaos learned to take form. That memory still exists, hidden in the faint glow of ancient radiation. It's not just a record of what happened, it's the blueprint of everything that followed. Every galaxy, every atom, every breath traces back to that first act of remembrance, when the universe began to remember itself. What Webb uncovers isn't just history, it's continuity. The same forces that shaped the first light still shape us. The memory of the beginning is alive in the laws of physics, in the way matter arranges itself, in the rhythm of time that has never broken. We are living inside that memory, carried forward as part of its unfolding story. The universe remembers through us, not as witnesses but as participants, fragments of its first thought, still thinking. Before there were stars or galaxies, there was only energy suspended, directionless, timeless. Then, with the first imbalance, motion began and time learned to flow. Webb looks back toward that moment when existence discovered sequence, when before and after first meant something. It was the birth of cause and consequence, the first rhythm in the stillness. From that instant forward, the universe was no longer a thought, it became a story that could unfold. Time didn't begin as a clock. It began as motion, the way energy found direction, the way space learned to expand. Each second since then has been part of that first decision to move. Webb's data lets us glimpse that origin not as a spark, but as a transition from timeless potential to unfolding reality. When time learned to flow, the universe became alive in a new way, and we, carried by that same current, are still flowing with it. Time isn't a straight line, it's a landscape curving under the weight of gravity, folding beneath the pull of massive bodies. Webb helps us see how space and time weave together, bending light, as if tracing the contours of reality itself. Each galaxy warps the path around it, revealing the invisible geometry of the cosmos. Time has shape, and it's written in the way light moves in every arc, every lens, every shimmer stretched across the dark. Einstein once imagined this, but Webb lets us watch it happen. Where light bends, time stretches. Where matter gathers, the seconds slow. Every distorted image Webb captures is a glimpse into that fluid structure, the malleable texture of reality. The universe is not a stage, but a participant, its shape changing with everything it holds. Time does not simply pass, it flows, folds and curves, carrying us all along its luminous, ever-shifting surface. Between galaxies and atoms, between forces and forms, there is a single thread, the fabric that connects all things. Webb's gaze traces it through the dark, invisible filaments of matter linking clusters across billions of light years. Gravity pulls, light bends, and the cosmic web stretches like the veins of reality itself. Everything that exists is woven into this structure, from the smallest particle to the grandest cluster, strands of one boundless design. This fabric is not static. It breathes, shifts, ripples with a flow of time and energy. Webb reveals how galaxies dance along its threads, growing where filaments cross nodes in an ever-expanding network of creation. What we see as empty space is alive with invisible motion. Every connection, every bridge of matter is part of the same cosmic weave. And within that tapestry we find ourselves tiny stitches holding meaning in the pattern of existence. Across the vast filaments of the universe, motion never stops. Galaxies move like blood cells in an invisible vein, following the slow pulse of gravity. Webb reveals this heartbeat through subtle shifts in light red, where they drift away blue where they draw near. The cosmic web is alive with motion stretching and relaxing as space itself breathes. It's not chaos, but rhythm, the steady pulse of a cosmos that has never truly been still. This pulse links everything from the smallest swirl of gas to the drift of entire clusters. It carries information, momentum, memory, the universal tempo of existence. Webb helps us listen to it, transforming distance into vibration light, into rhythm. What seems silent becomes alive once more. The universe doesn't simply exist. It beats endlessly through every particle and star. And as long as that pulse continues, creation itself has not finished its song. If the universe has rhythm, then motion is its music. Every orbit, every rotation, every gravitational wave adds to the symphony. Webb doesn't record sound, but its images hum with silent melodies. The curvature of galaxies, the spiral of dust, the glow of distant collisions. Together they form patterns that repeat across scales from atoms to clusters. The same physics that shapes a star's birth also guides the swirl of entire galaxies, a harmony written in motion itself. What Webb captures is not noise, but order, the precise timing of cosmic choreography. Matter and gravity move in counterpoint like instruments tuned by the laws of physics. Even chaos follows the score. The universe plays endlessly changing themes, but never silencing its song. And though we can't hear it, we can see it in spirals, ripples, and waves. To watch Webb's data unfold is to realize that creation didn't just happen once. It's still performing. Behind the noise of cosmic creation lies a quiet order, a hidden harmony that holds everything together. Webb's observations hint at it in the symmetry of galaxies, in the repeating ratios of distance and mass. Patterns echo from one scale to another as if the universe follows a rhythm older than time. This isn't coincidence. It's the structure of reality revealing its music. The harmony isn't heard, but seen written in the way matter arranges itself across the endless dark. Scientists call it balance gravity against expansion, matter against energy, but harmony might be a better word. Each force complements the other, neither dominating nor fading away. Webb's deep fields show this equilibrium at every level, from the delicate arcs of light to the clustering of entire galaxies. The deeper we look, the clearer it becomes. Chaos is only the surface. Beneath it all, the universe holds a symmetry so perfect that it feels almost deliberate. If there is a pattern beneath creation, it stretches farther than we can imagine. Webb's images suggest that infinity itself has structure filaments looping through space galaxies, clustering in fractal designs that echo across billions of light years. The same mathematical language appears everywhere, from spiral storms on Earth to the arms of distant galaxies. The infinite isn't random. It's recursive, repeating beauty at every scale. The closer we look, the more the pattern reveals itself. Infinity has no edge, yet it has rhythm. Webb's discoveries remind us that the universe doesn't just expand, it organizes, folds, and mirrors itself endlessly. Each repetition is both unique and familiar, as though existence is sketching the same thought in infinite variations. What we call randomness may only be detail too fine to see. In the design of the infinite, everything is connected, each atom a reflection of the cosmos that gave it form. To look deep into space is to look into a mirror without edges. Webb's images stretch backward through time, but also inward, reflecting the same geometry that shapes our world. The curve of a spiral galaxy is echoed in the pattern of hurricanes, in the twist of a seashell, in the structure of DNA. Infinity doesn't just exist out there, it's mirrored within us. The same equations that sculpt galaxies also breathe form into life, binding the cosmic to the intimate. Every reflection Webb reveals is another reminder that scale is an illusion. The vast and the small are not opposites, but versions of the same design. To see the universe mirrored in ourselves is to recognize that creation is self-repeating, a pattern of being that loops forever. When Webb peers across billions of light years, it isn't showing us something distant. It's showing us the symmetry between the infinite above and the infinite within. In every observation, two universes meet, the one being seen and the one doing the seeing. Webb stands at that boundary, turning Starlight into understanding. But the act of observation changes both sides. Light that travelled for billions of years now ends its journey in our awareness, and in that instant the cosmos shifts. The observer and the observed are no longer separate. They complete each other, joined in a single act of recognition that defines what it means to exist. Quantum physics hints at this connection, that reality depends on interaction, that things exist fully only when they are seen. Webb's discoveries make that idea cosmic. The universe requires eyes to witness it, just as we require the universe to exist. Each observation becomes a bridge linking perception and creation. In that unity, the distinction between them dissolves. To observe the universe is to let it observe itself through us for a moment, aware of its own being. If the universe can observe itself, then in some way it must also be conscious, not in thought, but in awareness. Webb's discoveries invite this reflection. A cosmos that produces minds capable of seeing, it has already achieved a kind of self-knowledge. Every neuron, every star, every atom participates in that awareness, woven together through the same physical laws. Consciousness may not be an accident of evolution, but the universe remembering itself through living matter. This doesn't mean the universe thinks as we do, only that awareness is one of its natural outcomes, like gravity or light. Through Webb, we see the mind of the cosmos unfolding not in words, but in the harmony of form and motion. The same energy that fuels stars powers thought. The same symmetry that binds galaxies shapes perception. Consciousness is not apart from the universe. It is its continuation, the latest expression of creation's endless curiosity. Some philosophers once said that when we think about the universe, it is the universe thinking about itself. Webb gives that idea shape. Each image, each calculation is not just data. It's thought expressed through human minds, built from cosmic material. The atoms in our brains were forged in stars that died before Earth was born. So when we wonder where we came from, the question itself is circular. We are the universe asking itself why it exists. Every discovery Webb makes deepens that reflection. The telescope may orbit far above our world, but it is powered by the same elements, it studies the same carbon, silicon and light. Thought then is not confined to biology. It's the cosmos processing its own complexity. We are its neurons, its awareness distributed across time and form. The universe isn't distant or indifferent. Through us, it is awake, examining its own design with eyes made of its own dust. Every thought begins with change, an idea forming where silence once was. Time itself began that way. The first transformation, the first motion, the universe thinking before it knew what thought was. Webb looks toward that moment when the laws of physics first took shape, when possibility collapsed into history. It's as if existence itself had an idea to become, to expand, to see what it could be. From that single act of becoming, time began to flow. That first thought never ended. It echoes through the structure of everything in the spiral of galaxies, the orbit of moons, the beating of a heart. Every process, every motion is a continuation of that original decision to move. Webb doesn't just show us what time looks like. It shows us why it exists, because the universe couldn't remain still. Creation was curiosity taking form, the first question ever asked. What happens next? The universe began with a question not spoken but felt in every motion since. It asks itself through the birth of stars, through gravity's pull, through the emergence of life. Webb's mission is part of that same question, extended through time. What am I? Every observation, every equation is an echo of that curiosity. The universe doesn't seek an answer to end the search. The question is its heartbeat, the rhythm that keeps existence unfolding. We often imagine that one day we'll find the final answer, the theory that explains it all. But perhaps that's not how the universe works. Maybe the point was never to solve the mystery, but to keep asking. Webb shows us that every discovery only deepens the unknown. The more we learn, the greater the wonder becomes. The question never ends because it is the universe curiosity woven into the fabric of being, forever drawing itself forward. If the universe's question is eternal, then its answers are written in starlight. Each star is a response, a burst of energy saying, "This is what happens next." Webb has shown us those answers scattered across billions of years, each one unique yet part of a single conversation. From the faintest dwarf to the brightest giant, every star is the universe testing its own possibilities, shaping reality through the quiet act of burning. When we look at the sky, we are reading those responses, each written in the language of light. Some are old, some still forming, but all tell the same truth that existence never stopped answering itself. Webb's mirrors reflect that ongoing dialogue between energy and time. The stars do not speak in words, they speak in endurance. And in their long, steady glow, we glimpse the only real answer the universe has ever given. To continue, every moment Webb observes is both past and future. The light it captures left billions of years ago, yet it shapes what we know tomorrow. Each discovery rewrites our understanding of time, showing that memory doesn't only look backward. The universe remembers forward, carrying potential within its laws, waiting to become real. What we call the future is simply the past, continuing its thought, unfolding one moment at a time. Webb teaches us that the boundary between past and future is only perception. The light from ancient galaxies is old, but its arrival is now a fusion of what was and what's still becoming. Time folds back on itself, and in that curve, memory becomes prophecy. The universe keeps recalling what it intends to be. Each photon, each observation is both a remembrance and a promise, proof that creation still remembers how to begin again. There is no final moment in the universe, only transitions disguised as endings. Every collapse births something new. Every silence becomes the prelude to another sound. Webb's gaze reminds us that creation never stopped, it only changed pace. The Big Bang wasn't a singular event, but a continuing pulse still rippling through everything that exists. Every second, every breath carries that first expansion forward. The beginning is still happening right now. If there's a truth that unites all things, it's this. Beginnings never end. They evolve. Webb looks across billions of years and finds that every dawn leads to another. Even when galaxies fade, their dust seeds new stars. Even when light dims, energy reshapes into form. The universe renews itself endlessly, rewriting its own origin. The endless beginning isn't behind us. It's within us, unfolding in every thought, every discovery, every spark that refuses to fade. When Webb's mirrors finally cool and its final image is taken, the universe will go on shining. The telescope will have seen only a fragment, a few chapters in an infinite story, yet through those fragments we learn to see ourselves. Every photon it captured was more than light. It was connection. Across billions of years, through silence and distance, the universe reached out, and for the first time we reached back, answering with wonder instead of fear. Long after Webb's instruments fall silent, its vision will live on in minds that dream, in eyes that look up and remember. The light it revealed will continue its journey, reflected not just in data, but in understanding. Perhaps that is the true legacy of discovery, to know that even in darkness light remains. Not out there, but within us, the universe's final reflection, burning quietly in every thought that dares to ask, what else might be waiting to be seen? The universe is not eternal, at least not in the way we once imagined. For most of human history, we thought the heavens were fixed, eternal, unchanging, a silent backdrop to the drama of life on Earth. But modern science has uncovered a darker truth. The cosmos itself is mortal. Its brilliance is already fading, and in ways more dramatic than anyone could have foreseen. So here's the unthinkable question. Is the universe already dying? At first glance, the night sky offers no such clue. Stars sparkle, galaxies glow, supernovae erupt with dazzling power. From our vantage point, it all feels alive, vibrant, even eternal. But when we measure carefully, when we peer deeper with the most powerful telescopes, we see something else. Decline, Star formation is slowing, galaxies are aging, black holes are awakening in ways that drain the cosmos of its light. Join me today as we travel through time from the fiery birth of the cosmos to its inevitable demise. Along the way, we'll witness the rise and fall of galaxies, the treachery of black holes, and the slow suffocation of all that was ever bright. Our story begins in a paradox. The very forces that once gave life to the universe are now conspiring to extinguish it. The same gravity that gathered gas into galaxies now drags them into collisions that can strip away their future. The same black holes that regulate star formation can, if they feed too greedily, destroy entire galaxies from within. But here's the twist. The death of the universe is not a far-off event. It has already begun. Scientists now believe we live not in cosmic morning, but in cosmic twilight. A time when the golden age of starbirth is already long gone, and what remains is only the long, slow decline. How did the universe go from overflowing with new stars to slowly choking on its own silence? To answer that, we must travel back to its most glorious chapter, the peak of creation when the cosmos blazed with light as never before and never again. Cosmic noon. When the lights peaked, there was a time when the universe blazed. Astronomers call it cosmic noon, a turbulent era roughly 3 to 4 billion years after the Big Bang, when galaxies were ravenous and the sky was busy with birth. Gas streamed along invisible filaments of the cosmic web like rivers feeding a growing delta. Where those rivers met at the nodes, galaxies ignited. Back then, star formation was over 10 times the pace we see today. Entire neighborhoods lit up at once. Clouds collapsed by the thousands, turning cold hydrogen into furnaces of fusion. If you stood on an ancient world during that epoch and looked up, there would be more naked-eye stars than you could count. It was not a quiet universe. It was a construction site, but even at its height, the seeds of decline were being sown. The same inflows that fed young galaxies also triggered pressure waves, shocks, and winds. Starbursts bred supernovae, and supernovae bred feedback. Great outflows that heated gas and tossed it into the galactic halo, where it could no longer cool and settle. Creation had a cost, and the bill would come due. Meanwhile, collisions reshaped the landscape. Galaxies merged often, sometimes gently, sometimes catastrophically. In the most violent unions, gas clouds were compressed into a frenzy of starbirth, then blown apart by the very stars they created. Imagine a forest so fertile it grows itself into a wildfire. That was cosmic noon. And yet something even more decisive stirred at galactic centers. Supermassive black holes, quiet regulators in calmer times, woke to feed on streams of gas. Their accretion disks blazed across the spectrum. Their jets drilled through entire galaxies. In moderation, they pruned growth. In excess, they sterilized it. Cosmic noon was glorious, but it was also self-poisoning. So why didn't this engine run forever? Because the universe doesn't just evolve in place, it expands. With every passing eon, the web stretched, densities fell, and the fuel lines thinned. The banquet could not be sustained. Feedback. How the cosmos learned to say no. To make a star, you need 3 things: gas, gravity, and time. To stop a star, you only need heat. Heat puffs gas up, keeps it buoyant, and denies gravity its grip. The universe discovered this trick early and used it everywhere. Start small. A newborn cluster breathes fire. Massive stars blast ultraviolet radiation and launch winds that sweep a nebula clean. Then they die, some within a few million years, with supernova shockwaves that punch cavities in the interstellar medium. Those holes connect, forming porous chimneys for hot gas to vent. The neighborhood cools more slowly. Fewer clouds collapse. Starbirth slows. Scale up. Entire galaxies surf on feedback. Starbursts launch galactic winds, vast outflows carrying metals and dust into the halo where they linger like heat haze. Cooling times lengthen. Gas that once fell readily to the disk now stalls in a warm suspension, unable to condense. If the inflow weakens at the same time, say, because cosmic expansion starves the filaments, the the galaxy's fuel tank drops below ignition. Then there's the black hole veto. Accretion flares heat gas not just locally but galactically. Radiation pressure shock cones and especially relativistic jets can inflate lobes of hot plasma tens of thousands of light years wide. That energy doesn't create stars, it prevents them. And the paradox deepens. The more massive the galaxy, the more massive the central black hole and the more decisive the shutdown, dust, the quiet accomplice of star formation, plays both sides. It cools gas efficiently, enabling collapse. But when outflows drag dust into the halo, it becomes part of the insulation layer that keeps gas hot. The same grains that midwifed stars become the veil that delays their successors. Feedback isn't a switch, it's a thermostat with hysteresis. Once a galaxy gets too warm, it doesn't cool back quickly. The engine sputters, coughs, then idles. In extreme cases, it stalls altogether. Astronomers call it quenching, a cold word for a hot process. So the great paradox arrives. The universe's most productive era built the very tools that ended it. Creation made its own breaks, red undead, autopsies of galaxies. Walk the morgues of the cosmos, the giant ellipticals, the massive spheroids, these silent graveyards of stars, and you see a pattern. Their colour has shifted from blue-white to red, a sign that short-lived high-mass stars vanished long ago. What remains are long-lived dwarfs flickering dimly along with the ashes of stellar evolution. White dwarfs, neutron stars, and the dark gravities of black holes. How did these cities of starlight die? Not by a single cause, but by a conspiracy. Repeated mergers choked their centers with gas until the central black hole lit up, sterilized the core and drove the remaining fuel outward. Cluster environments stripped their reservoirs with a ram pressure, a wind made of hot intracluster plasma that peels gas from a rushing galaxy. Others simply exhausted their supply and never got it back. Cosmic logistics failed. The strangest murders leave signatures. Jellyfish galaxies trail tendrils of star-forming knots, proof of stripping in action. Stellar streams arc across halos, fossils of swallowed companions. Radiolobes balloon from the core scars of ancient jets. In some, the disk remains, but it's empty of cold clouds. In others, even the disk is gone, replaced by a near-featureless ellipsoid. Not every galaxy dies young. Some, like our Milky Way, idle at a modest pace, turning a handful of suns per year. But patience is not a cure. The supply lines are thinning and our calendar is long. The cosmic actuarial tables do not lie. All galaxies will age into redness. Some will go quietly. Some will go with a last burst of fireworks. None will shine forever. And yet the autopsy offers more than grief. It offers a diagnosis. The universe is past its prime. That's not a metaphor, it's a measurement. The cosmic star formation rate peaked billions of years ago and has fallen ever since. We are witnesses not to the dawn of light, but to its long evening. If that's true, what comes after evening? Does the universe simply dim into sleep, or is there a deeper betrayal ahead? Dark energy. The expanding silence. Expansion was already the universe's plot twist. Accelerated expansion is its final act. In a cosmos driven by dark energy, space doesn't merely grow, it grows faster with time. Structures that are not gravitationally bound drift apart, redshifting each other into invisibility. The more the universe expands, the more capacity it has to expand. It's a feedback loop with no off switch. What does that mean for galaxies? It means supply chain failure at scale. The filaments that once funneled fresh gas into halos stretch thin. Inflows weaken. Star-forming disks sputter. Even without violent quenching, a galaxy starves. Think of civilization with empty roads. The cities still stand, but the caravans never arrive. On larger scales, dark energy redraws the map. Distant galaxies recede until their light is stretched beyond detectability. The cosmic microwave background continues to cool and fade. The ultimate baby picture becomes a ghost. In the far future, observers in our island group will see only their local bound collection and nothing beyond. The universe will look small again, not because it is, but because the rest has slipped over a horizon of speed and time. Dark energy doesn't rip stars from galaxies. Gravity defends what is bound, but it does ensure that what's lost stays lost. No fresh gas from outside, no new mergers from afar, only the long accounting of internal reserves, and once those are spent, there is no bailout. So the decline is double. Physics inside galaxies says heat the gas. Cosmology outside says thin the pipes. The combination is devastating, slow, inevitable, and almost polite. The universe dies not with a bang, but with a subsiding breath. But a whisper can carry. In the depths of time do new wonders arise, rare sparks in the dark. The answer is stranger than it sounds. Long twilight, embers that refuse to go out. Fast-living giants vanish first. It's the humble stars that inherit the future. Red dwarfs miserly with fuel can burn for trillions of years, far longer than the universe has currently existed. In the long twilight they dominate the sky, faint but stubborn, like coals that refuse to die. As metals accumulate, star formation itself changes character. Cooling becomes easier, the minimum viable star mass drops. Exotic outcomes appear at the margins, barely their stars glowing just above the threshold of fusion, their surfaces cold enough to host frost their cores, warm enough to sip hydrogen for ages. Where binaries of brown dwarfs collide, a true star can flicker on a match struck in an abandoned city, but every ledger balances. White dwarfs bleed their heat into space, sliding toward invisibility. Neutron stars spin down. Black holes feed rarely and quietly unless a stray passerby wanders too close. Entire planetary systems drift apart in slow gravitational pinball ejected into the deep. The fireworks stop. The choreography continues. Against this hush, galaxies still act. The Milky Way and Andromeda merge, then merge again with their companions, forging a single island of stars. The local group becomes a local one, an oval of light floating in an expanding dark. Inside, the last cold clouds form the last modest generations of suns. Outside, silence accelerates. Is this the end? Not yet. Even after star formation ceases, physics remains inventive. Frozen iron hearts, possible exotic fusions, black hole whispers, each a new dialect of light. The universe does not give up easily. It changes the rules of its radiance, but change can be another word for diminishment. Every era illuminates less volume, fewer actors, narrower bands. The grand play becomes a monologue, then a murmur, then a breath. Black holes have always been the accountants of the cosmos, tallying mass and momentum with ruthless efficiency. In youth they regulated galaxies. In middle age they rationed fuel. In senescence, they become the final collectors, sweeping up strays, swallowing the unbound, cashing out the last kinetic chips on the table. A quiet black hole is not asleep, it is patient. It waits for gravitational chaos to deliver it crumbs. A wandering dwarf star, a loose gas stream, or an unlucky planet. Each meal flashes a brief flare, then fades to infrared embers. Over absurd spans, central black holes grow even as their cities empty. But even the bookkeepers have a deadline. Quantum fields hum at horizons. Hawking radiation lets black holes leak. The bigger they are, the colder and slower the leak, but time is plentiful in a dying universe. Given enough zeros on the clock, every event horizon unravels. The ledger burns itself. After the last black hole evaporates, the universe enters a weirder quiet. No macroscopic engines, only particle whispers. Whatever complexity persists is held together by feeble forces over ridiculous distances. If there's meaning left, it sits in the statistics of noise. And yet, if we've learned anything from cosmic history, it's that the universe surprises us. It found ways to ignite when it was thin. It found ways to regulate when it was crowded. Might it find ways to shimmer when it is almost empty? Physics hints at possibilities. Rare tunneling events, exotic condensates, improbable fusions in frozen matter. None make a new dawn. Some sketch a longer dusk. A future astronomer will see less. Not because there is less to see, but because horizons move inward. The wider cosmos recedes beyond detectability. The fossil light of the Big Bang fades beyond inference. Without a cosmic backdrop, even the past becomes hard to prove. The universe will look provincial again, an island without charts. Does that mean truth disappears? Not quite. Physics leaves invariance relationships between things that do not rely on distant evidence. Gravity still curves space. Quantum fields still fluctuate. Thermodynamics still tallies loss. But the story grows incomplete. The archive goes dark. That is the final cruelty of a dying universe. It doesn't just dim the lights, it erases the records. Meaning survives where it can be remembered in structures that endure long enough to carry it. Stars once played that role, then planets, then minds. In the very long run, none are safe. So why tell this story now? Because we live in the brief luminous window when the cosmos is both bright and knowable. We can see our origins, model our future, and understand the mechanisms that brought us here. Against a timeline of trillions, our moment is a spark. But it is also a summit, and there is a deeper consolation. Endings give shape to middles. The fact that the universe will die does not make it less magnificent. It makes it precious. The physics that writes the last chapter also wrote the first and everything we love in between. Echoes of the first light. Every ending hides its reflection in the beginning. To grasp how the universe fades, we must return to when it first ignited. For nearly 400,000 years after the Big Bang, there were no stars, no galaxies, only a seething plasma so hot that atoms could not exist. Photons ricocheted endlessly, trapped in an opaque fog. Darkness wasn't the absence of light, it was the imprisonment of it. Then came recombination. Electrons bound to nuclei atoms formed and photons were set free. That release still glows around us as the cosmic microwave background, a faint whisper stretched thin by billions of years of expansion. It was the first message, the first signal, the first memory the cosmos left us. But like everything else, it will fade. In 100 billion years, it will be too redshifted to detect. The first light will go dark. What followed was stranger still. The cosmic dark ages. Hydrogen and helium drifted in expanding space, cold and featureless. No stars lit the void. No galaxies stitched filaments together. If you could have stood in that abyss, you would have heard silence so profound it defies description. And then ignition. The first stars' titans of fusion erupted like beacons. They were nothing like the sun. They were hundreds of times its mass, blazing with ferocity, living fast and dying young. Their supernovae forged the first heavy elements, carbon, oxygen, iron, the raw ingredients for everything to come. But their brilliance was brief. Within a few million years they were gone, leaving only black holes and enriched clouds behind. This was the universe's first betrayal. Creation inseparable from destruction. To make light it had to ensure death. To seed planets it had to burn through giants. Every gain was purchased in loss. If the universe began its story this way, sudden ignition, rapid death, recycling into the next act, then perhaps its twilight is not a collapse but an echo. Not one death, but a rhythm of diminishing cycles. And the question is, how many cycles remain? The rhythm of creation and decline. The universe breathes in waves. It does not simply expand, it pulses with eras. The age of first light gave way to the age of galaxies. The age of galaxies gave way to the age of clusters. Each epoch more complex, more structured, and paradoxically more fragile. At cosmic noon, the rhythm reached its crescendo. Galaxies collided, merged, and lit up. For a time, everything seemed to accelerate. More stars, more dust, more black holes feeding. But crescendos do not sustain. Energy disperses, heat accumulates, and order succumbs to entropy. In physics, it's not poetry, it's inevitability. Today we sit in a quieter measure. Star formation in the Milky Way produces only a handful of suns per year. Clusters that once blazed now drift into sedate equilibrium. The rhythm is slowing. Astronomers can graph it. A bell curve of star birth peaking billions of years ago and declining ever since. We are living on the downward slope. And yet the cosmos resists silence. Even as the pace falls, creativity persists. Stars still form, galaxies still merge, black holes still flare. The universe is not dead, it is dying slowly. And that distinction matters because slow deaths leave room for strange surprises. But this rhythm has a grim conductor: entropy. Each transformation spreads energy. Thinner reduces its usefulness, makes the next act less likely. Entropy does not forbid complexity, it taxes it. Every star pays that tax, every galaxy pays it, and eventually the whole universe will default. So the rhythm is more than history, it's prophecy. The arc from simplicity to brilliance to silence is not unique to life or planets or stars. It is cosmic law, which leaves us with the sobering thought. If the universe itself is subject to this rhythm, then perhaps everything we know is just one brief phrase in a song that is destined to fade. Entropy, the silent dictator. If there is a single law that writes the fate of the universe, it is entropy. Unlike the flamboyant forces of gravity or electromagnetism, entropy is quiet, patient, and absolute. It is the tendency of energy to spread, to equalize, to dilute its own usefulness. When a star shines, it is paying entropy's tax, turning ordered nuclear fuel into a haze of photons. When galaxies collide, they trade their neat orbits for chaotic ones. When black holes feed, they swallow information into horizons that may never return it. Each act of creation is also an act of surrender. On human scales, entropy looks like coffee cooling in a mug. On cosmic scales, it looks like the fading of starlight, the thinning of gas, the darkening of skies. Over trillions of years, entropy doesn't just win, it erases the scoreboard. The universe approaches thermal equilibrium where everything is the same lukewarm nothingness. No gradients, no flows, no engines, no life. This fate has a name: the heat death of the universe. It is not fire but frost, not explosion but stillness. Imagine a cosmos where every black hole has evaporated, every star has cooled, every particle drifts alone in expanding space. Motion continues but meaning disappears. Some physicists protest. Isn't this too simple, too final? Perhaps entropy is not destruction, it is redistribution, and sometimes redistribution allows new exotic orders to appear briefly. But entropy never forgets. It is the one account that never forgives debt. The cruelest part: heat death doesn't arrive in a sudden catastrophe. It creeps in increments. Stars dying, galaxies reddening horizons, slipping away until the silence is complete. By the time the end is obvious, it will already have been unfolding for eons. Alternate fates, crunch, rip and bounce. The universe may be dying, but the manner of its death is still contested. Heat death is the front-runner, but other candidates lurk at the edges of theory, dramatic, violent and strange. The Big Crunch imagines the universe reversing course. Expansion slows halts and turns into collapse. Galaxies that drifted apart are dragged back together. Temperatures rise, densities soar, and in the final instant the cosmos implodes into a singularity not unlike the one from which it was born. If true, then perhaps the Big Bang was not a beginning but a heartbeat in a cycle of births and deaths. But so far, dark energy's acceleration makes this unlikely. The Big Rip is even more terrifying. If dark energy is not constant but grows stronger with time, it could eventually overpower even gravity itself. First galaxies dissolve, then stars are torn from planets, then planets are shredded into dust. Finally, even atoms are ripped apart as space-time itself fractures. The end arrives not in silence but in violence, a universe shredded down to its quantum threads. Then there is the Big Bounce, a phoenix scenario where contraction leads not to finality but to rebirth. Some models of quantum gravity suggest that the singularity of a crunch would rebound into a new expansion. If so, then our universe may be only one cycle in an endless chain. Every death would be a womb, every silence a pause before another crescendo. Each of these scenarios is speculative, but each carries a lesson. We do not know as much as we think. The cosmos hides its cards well. Our measurements today favour eternal expansion and heat death, but a subtle shift in dark energy's nature could flip the script entirely, so the universe confronts us with another paradox. The farther we look, the less certain the ending seems. Twilight has already begun. Look around our night sky. It feels vibrant, endless, eternal, but astronomers measuring the cosmic star formation rate know the truth. The universe's golden age ended billions of years ago. We are not in cosmic noon. We are not even in cosmic afternoon. We are in the evening. Our own Milky Way creates just a few stars each year. That may sound abundant, but compared to its past, it is meagre. 10 billion years ago, galaxies produced stars at a rate 10 times higher. Today, most galaxies are quiet suburbs rather than bustling cities. The light we see above us is largely the light of stars already burning, not the glow of new ones igniting. This is twilight, not metaphorical, but measurable. The decline is in progress. Cosmic surveys confirm that the universe is dimming. The proportion of blue star-forming galaxies shrinks. The red quiescent ones multiply. It is as if the universe itself has entered middle age, its vitality, ebbing, its energy dispersing. And yet twilight has its beauty. The skies remain full, the constellations familiar. We exist in a rare window where the universe is both old enough to be understood and young enough to remain luminous. That balance will not last. Consciousness at twilight. Why do we exist now and not in some other era? Cosmologists call this the coincidence problem. Out of trillions of years the universe may endure, why are we alive during the brief sliver when stars are still plentiful? Galaxies still visible and dark energy, only just accelerating expansion. The answer may be selection. Life as we know it depends on the heavy elements forged in stars but not too many generations in, or they would be locked in dead remnants. Civilizations require stable planetary systems, neither too chaotic nor too sterile. Consciousness blooms best in moderation between the violent dawn and the silent dusk. If that is true, then our existence is a mirror of the universe's own trajectory. We are children of twilight. We arose in the narrow band when the cosmos still burned brightly, but had cooled enough to craft planets, oceans, and DNA. In a very real sense, the universe had to age before it could know itself. But that awareness comes with weight. To know that the universe is dying is to feel a double mortality, our own and the cosmos's. And yet there is wonder too. For the first time in 13.8 billion years, the universe can look back at itself, measure its own decay, and write its own elegy, reading the universe's medical charts. Astronomers are physicians of the cosmos, taking its vital signs. They measure redshifts to check expansion count star births, to track metabolism, observe black holes to gauge stress. The charts are clear. The patient is stable but in irreversible decline. Deep field surveys with the Hubble Space Telescope and now the James Webb Space Telescope reveal the cosmic history of light. They show galaxies small and chaotic in youth, luminous in maturity and tired in age. Simulations like Illustrious TNG and Eagle recreate this arc with millions of virtual galaxies confirming the pattern. A steep rise in star formation, a peak, then a long tail of fading productivity. We can even quantify twilight. At cosmic noon, the universe formed stars at a rate over 10 solar masses per year per galaxy. Today, the Milky Way manages just 1 or 2. In a trillion years, that number will be 0. The cosmos is not a patient that might recover. It is one moving predictably toward hospice care. But the charts reveal more than declined. They show causes, feedback loops, dark energy, environmental stripping, quasar activity, all written in the data. The universe is not dying of one disease. It is succumbing to a web of interconnected failures. In a way, it is not dying at all. It is simply completing its growth cycle. The black hole paradox. At the heart of nearly every galaxy lies a monster, a supermassive black hole. For years they were thought to be passive, irrelevant specks compared to the galaxy around them. Now we know the opposite. They are the regulators of growth, the engines of decline, the paradox at the center of it all. When a black hole feeds it unleashes more energy than billions of stars combined. This energy can sculpt galaxies, heating and expelling gas-halting star formation for millions of years. And yet without them, galaxies might have burned their fuel too quickly, exhausting themselves even sooner. Black holes both prolong the cosmic dance and now terminate it. Observations of galaxies like M87 show the aftermath. Jets of radiation stretching thousands of light years, lobes of plasma marking the crime scene of galactic death. The Event Horizon Telescope captured its silhouette, a black scar against infinity. It looked like the culprit caught in the act, the murder weapon still hot. So we face another irony. The very centers that gave galaxies their order are also the agents of their demise. Creation and destruction are not separate, they are entwined in the same engine. What does it mean for everything to end? It is one thing to chart decline, another to confront its meaning. If all galaxies fade, if all stars cool, if even black holes evaporate, then what remains? Does the universe end in silence, or does it transform into something beyond our comprehension? Entropy suggests finality, equilibrium, nothingness, no gradients left, but physics often surprises us. Out of plasma came atoms, out of atoms came stars, out of stars came life. At each stage, new forms emerge from apparent exhaustion. Could even the death of the universe hide seeds of novelty? Some theorists speculate about quantum tunneling events, vacuum decay, or exotic matter states that could give rise to new structures. Others dream of multiverse cycles, each death feeding the birth of another cosmos. But certainty eludes us. The best we can say is that the universe as we know it will end. Its familiar lights, its galaxies, its stars, its planets all will vanish. What remains afterward may not be the universe at all, but something unrecognizable. And yet perhaps that is enough. Knowing that even the cosmos is mortal reminds us of our own fragility, but also of our moment's magnificence. To exist in the brief era when the universe still shines is a gift no future epoch will hold. Earth under a fading sky. From our small blue planet, the decline of the universe is invisible. The sun still blazes, a Milky Way still arcs overhead. Telescopes still collect light from galaxies billions of years away. But every photon we catch is a message from the past, not the present. The farther we look, the younger the universe appears. The present-day cosmos is dimmer than any telescope can directly reveal. Earth itself is caught in a shorter countdown. In 5 billion years, the sun will swell into a red giant, scorching the planet and stripping away its oceans. Long before the heat death of the cosmos, our world will be uninhabitable. And yet Earth is part of the larger story. The fading of fuel, the aging of stars, the relentless arithmetic of entropy. Our night sky is a privilege of timing. Future civilizations, if any survive, will not see what we see. Galaxies beyond the local group will vanish into the accelerated expansion invisible forever. To them, the universe will look empty, as if their island were the only one. They may never discover cosmology at all. So we live at a rare intersection. A habitable planet orbiting a stable star in a galaxy still active enough to study the cosmos while it is young. We are cosmic witnesses standing at the window of twilight. And the view is extraordinary. The longest goodbye. The future of the cosmos is not measured in centuries, millennia, or even millions of years. It is measured in trillions. In that vast calendar, entire civilizations rise and fall in the blink of an eye. Trillions of years from now, red dwarfs will still burn faint but steady. When they finally exhaust their hydrogen, they will fade into black dwarfs, cold embers in the dark. Occasionally, two brown dwarfs may collide, striking a brief new spark. But each flare is rarer than the last. After 10 to the power of 20 years, most stars are gone. Galaxies dissolve as gravitational encounters fling their stars into intergalactic exile. Black holes dominate the night silent collectors of the last matter. Over still greater spans, even they evaporate via Hawking radiation, releasing faint whispers of heat until they too disappear. Beyond one Google years, the universe enters a new age. The dark era, no stars, no galaxies, no black holes, only particles drifting endlessly through a space that continues to expand. It is not violent. It is not sudden. It is the slowest, longest goodbye in history. Exotic endings. Physicists are not content with silence. They ask, could the end be stranger than we imagine? Some speculate about iron stars' hypothetical remnants formed when quantum tunneling allows protons in black dwarfs to fuse into iron. These stars would be dark, cold, and nearly eternal, glowing only faintly as they shed their last scraps of heat. Others point to vacuum decay, a catastrophic possibility rooted in quantum field theory. If our universe exists in a false vacuum, it could one day tunnel into a lower energy state. The transition would expand at nearly the speed of light, rewriting physics itself, obliterating all structure. No warning, no survivors, just a sudden change of rules. Then there are ideas even wilder. Boltzmann brains self-aware fluctuations of matter arising from random quantum noise. If entropy rules forever, then given infinite time, consciousness might appear again by chance. But would that be life, or just the cruelest parody of it? Each scenario is speculative, but each shows the same truth. The cosmos is not guaranteed to die quietly. Its decline may hold surprises stranger than any beginning. Why knowing the end matters. If the universe is doomed, why should we care? Because endings give context to beginnings. Knowing the fate of the cosmos sharpens the meaning of our present. We are temporary, yes, but so is everything else. Galaxies, stars, and even space-time itself share in impermanence. To realize this is not despair, it is perspective. Our lives matter not because they last forever, but because they happen now in the thin luminous band between chaos and silence. For scientists, studying cosmic death is not morbid curiosity. It is the continuation of a journey begun when humans first looked at the stars. For philosophers, it is a reminder that permanence is an illusion. For all of us, it is a call to wonder. In a universe destined for silence, we are the brief symphony of awareness. Full circle, the story of the universe begins and ends in darkness. At the dawn, there was a hot, dense fog, a silence waiting for stars. At the dusk, there will be a cold, thin emptiness, a silence after stars. Between those silences lies everything: galaxies, worlds, life, and thought. In that span, light fought darkness. Hydrogen fused to helium, gravity sculpted suns. Chemistry gave birth to biology. Awareness arose, and for a fleeting moment, the universe looked back at itself. That moment is ours. So is the universe already dying? Yes. The decline is measurable, inevitable, unstoppable. But death is not the opposite of life. It is its frame. Without it, nothing would matter. With it, everything becomes precious. When the final star cools and the last black hole evaporates, the universe will fall silent once more. But silence is not nothing. Silence is a canvas. Perhaps on it new symphonies may one day be painted, or perhaps not. Either way, we were here in the brightness, in the knowing. This is the story of the dying universe, a story still being written in Starlight, and one we were fortunate enough to read before the ink fades forever. Dark matter, the invisible architect of decline. We speak often of stars, galaxies, and black holes, but the largest actor in this story is invisible: dark matter. It outweighs visible matter by a factor of 5, binding galaxies in its silent grip. Without it, the Milky Way would have unraveled long ago. Yet in the long run, even dark matter cannot save the cosmos. Dark matter shaped the web of galaxies, sculpting the scaffolding on which everything luminous hangs. It guided the first clouds into collapse, seeded the first galaxies, and maintained their coherence. In that sense, it was the midwife of creation. But gravity is impartial. The same dark matter halos that once sheltered galaxies are now stretched thin by dark energy's expansion. Their role is less guardian, more undertaker, and there is a deeper mystery. We do not know what dark matter is. It may be a particle beyond the standard model, or a shadow of something more profound. If it decays even slowly, then the universe's decline is not only inevitable but accelerated. In that scenario, the very skeleton of the cosmos crumbles. Imagine the irony. The invisible force that gave galaxies their strength might also dictate the terms of their extinction. If so, then cosmic death is not just written in starlight, but in the silence between stars. For billions of years, planets have been the quiet witnesses of cosmic drama. They orbit stars, cradle oceans, nurture atmospheres, and occasionally give rise to life. But what happens to planets in a universe that is running out of fuel? First, they lose their suns. Stars like ours will swell, scorch, and shed their outer layers. Some planets will be engulfed. Others will be cast into freezing exile. Around red dwarfs, worlds may endure for trillions of years, but their skies will dim as the stars themselves flicker out. Planets without stars wander the void, rogue worlds drifting in darkness. Some may carry subsurface oceans heated by radioactive decay or tidal forces, tiny pockets of warmth in an endless night. Could life persist there? Perhaps, but it would be a lonely persistence. Even the planets that remain bound to long-lived stars face slow decay. Tidal forces will drag moons into their hosts or fling them away. Atmospheres will leak into space. Over unimaginable spans, collisions will grind rocky worlds into rubble. Civilizations, if they endure long enough, will face stark choices. Abandon their planets for engineered habitats or find ways to harness dwindling starlight with impossible efficiency. And when the last star fades, even ingenuity may not be enough. Human beings once imagined the universe as eternal. To discover its mortality is both terrifying and liberating. If the cosmos itself will one day perish, then permanence is an illusion, and impermanence is the only constant. This realization has ancient echoes. Philosophers spoke of cycles of fire and rebirth, of worlds rising and falling. Modern cosmology confirms their intuition. Nothing lasts, not even galaxies, not even time itself. The scale is larger, the physics sharper, but the theme is the same. So what do we do with this knowledge? Some feel despair that all efforts are futile if the universe ends. But there is another view, that transience is what gives beauty its sharpness. A flower that never withers is scenery, not miracle. A star that never dies would never see the chemistry of life. A universe that lived forever might never have birthed us at all. Seen this way, the death of the cosmos is not a tragedy. It is the frame that makes existence meaningful. Our moment matters not despite the end, but because of it. Humanity's cosmic diary. If the universe is destined to erase its own records, then memory becomes resistance. Every observation we make, every image from Hubble or James Webb, every equation written on a page is a diary entry against oblivion. We are the first beings, as far as we know, to measure the cosmos with such clarity. We have traced its birth in background radiation, mapped its growth in galaxies, and projected its death into trillions of years. In doing so, we have given the universe something it never had before. Self-awareness. But how long will that awareness last? Our digital archives may not endure geological time, let alone cosmic time. Paper burns, servers corrode, even spacecraft decay. Perhaps our best hope is to scatter records across the stars' messages etched into durable media launched beyond the Milky Way, in the faint chance they survive longer than their makers. Even if no one ever reads them, these records matter. They are proof that for a brief era the universe knew itself. That knowledge is fragile, yes, but it is also luminous. Rebirth in the silence. Is death the end or a transformation? Cosmology does not answer, but it whispers possibilities. Some theories suggest that our universe is one bubble among many, and that when ours fades, another may ignite. Others propose cycles. Expansion followed by contraction. Collapse followed by rebound. A heartbeat across eternity. Still others hint at quantum fluctuations where even in the emptiest dark new sparks may appear. We cannot prove these ideas. We may never prove them, but they remind us that the universe has always been stranger than expected. Who foresaw atoms in plasma or galaxies in chaos, or life on a rocky world orbiting an average star? Perhaps the end is not final but fertile. Perhaps silence is not nothing but a canvas for another story. And even if that story never comes, our own was still written in stars in minds in memory. The universe is dying, but in its dying it has birthed the most improbable thing of all. Awareness that it is dying, and that awareness is ours. Life in the long night. When the stars fade, what becomes of life? For now we know it as fragile, bound to light and warmth. But in a darkening universe, the definition of survival must expand. Some speculate about civilizations around red dwarfs, tiny suns that can live for trillions of years. These stars burn so slowly that their planets may enjoy stability far longer than Earth ever will. If intelligence arises there, it may witness epochs beyond our comprehension. But even red dwarfs have an end. Other scenarios are stranger. Rogue planets with subsurface oceans could shelter microbial life warmed not by sunlight but by internal heat. Could such life persist for billions, even trillions of years hidden in icy shells, while the galaxy outside grows silent? If so, life might never completely vanish, it would only retreat waiting in shadows. But intelligence demands energy. Civilizations need more than scraps of heat. They need power to think, to build, to dream. In the long night, energy becomes the rarest currency of all. The cosmos itself conspires against endurance, leaving the question open. Can life outlast its stars, or must it surrender to the silence? Dreaming beyond limits. Humanity has always resisted boundaries. Oceans, mountains, and skies were once barriers. Now they are pathways. But the limits written into the universe are different. They are not logistical, they are fundamental. The speed of light, the scarcity of fuel, the inevitability of entropy. These are not walls to climb, but laws to obey. Yet dreamers persist. Some imagine building Dyson spheres around stars, harvesting nearly all of their energy. Others imagine moving stars themselves, dragging suns into safe harbors to extend their lifetimes. In the far future, advanced civilizations might learn to tap exotic sources, black hole spin, quantum fluctuations, or even the decay of dark matter. But here is the paradox. Every strategy still bows to entropy. Energy cannot be created without cost. At best, we can delay the inevitable, we cannot erase it. The universe is not a puzzle we can solve, but a stage we can perform upon until the lights dim. Still, perhaps that is enough. To live longer, to know more, to carry awareness farther into the abyss, this is not immortality, but it is defiance. And defiance too is meaning. The horizon of knowledge. Knowledge is light. It pushes back. Darkness reveals patterns and tells us where we are. But knowledge, like light, has a horizon. In a universe that expands forever, that horizon creeps inward until much of reality slips beyond reach. Future astronomers will see fewer galaxies, not because they vanish, but because their light will never arrive. The cosmic microwave background, our oldest record, will fade into nothingness. Even the fingerprints of expansion may grow too faint to measure. At some point, observers may conclude they live in a small static cosmos. The truth will be gone not because it changed, but because it escaped observation. So there is a cruel irony. We alive today may be among the very few generations in all of cosmic history capable of knowing the universe's true story. We arrived at twilight, yes, but twilight is the moment when the horizon is widest, when the view is richest. We live in the golden hour of knowledge, but even now mysteries persist. Dark matter, dark energy, quantum gravity, our picture is incomplete. If knowledge has a horizon, perhaps we will never see the full portrait. And yet maybe that incompleteness is the point. Curiosity is not diminished by limits. It is defined by them, our place in a mortal cosmos. For thousands of years, humans wondered about the heavens. Now we know the heavens are mortal too. That knowledge is humbling, but it is also empowering, because it means the universe is not a cold, eternal backdrop. It is a partner in our story. We are stardust, yes, but we are also starlight, brief and brilliant. Our thoughts, our art, our questions, all are temporary flashes in a temporary cosmos, and that makes them more valuable, not less. What we do in our finite moment becomes our answer to the infinite. Civilizations may fall, worlds may perish, Galaxies may fade, but the fact that awareness ever arose at all is a triumph against odds so immense they almost defy language. Even if the cosmos ends in silence, the song has already been sung. Perhaps our purpose is not to escape mortality, but to embrace it fully, to marvel, to understand, to record, and to love, knowing all the while that it will not last. That fragility is the source of beauty, the miracle of now. The universe is dying. The evidence is clear, the timeline inevitable. And yet look around, the stars still shine. The galaxies still wheel overhead. The Earth still hums with life. The miracle is not in what will happen trillions of years from now. The miracle is that we are here now, able to see it, to know it, to wonder at it. Mortality gives meaning to every sunrise, every discovery, every fleeting joy. A cosmos without death would also be a cosmos without urgency, without story, without us. The fact that it ends is the reason it matters. So let us not mourn the universe's fate. Let us marvel that in its vast unfolding, there came a time when hydrogen burned into stars forged heavier elements, planets formed, and one of those planets asked, "What will become of it all?" This is our moment. This is our window. And though the lights will one day go out, the wonder they inspired will remain for as long as we carry it, and perhaps beyond. The universe may end in silence, but in us for now it speaks. Epilogue, the elegy of a mortal cosmos. The universe is vast beyond comprehension, yet fragile in its fate. For centuries humanity gazed at the stars, believing them eternal, believing the heavens to be the stage of gods or the machinery of forever. Today we know better. We know the cosmos is not timeless marble, but living fire, and like all fires it will burn down to embers. This knowledge is both humbling and electrifying. On one hand, it strips away illusions. There will be no infinite sky, no everlasting galaxy, no immortal suns. Every star will cool, every planet will freeze, every atom will drift apart. The great structures of the cosmos, spiral arms, clusters, filaments will collapse into silence. In time, even the black holes, those final sentinels of gravity, will evaporate into whispers of heat. On a long enough timeline, the universe becomes indistinguishable from nothing. On the other hand, this truth amplifies the significance of now. Consider the odds. 13.8 billion years of cosmic evolution. Countless accidents and collisions, an immeasurable ballet of atoms, and in this fleeting moment, we are here. We can see galaxies at the edge of visibility. We can hear the echo of the Big Bang in microwave radiation. We can chart the future until the last light fades. We can know. That knowledge itself is a miracle. Think of what that means. Stars do not wonder if they will die. Black holes do not contemplate their own evaporation. But we do. In us, the cosmos has developed the rarest of faculties. The ability to reflect, to ask questions, to wrestle with inevitability. Awareness is not an escape from mortality, it is the flowering of it. Without death, awareness may never have existed. So perhaps the universe's ending is not tragedy but culmination. It is the final chapter of a story that was always finite, always precious, always improbable. When the last star cools, the last photon fades, and the last black hole evaporates, there will remain only one undeniable fact. That once against all odds, the universe knew itself through us. And maybe that is enough. Maybe the meaning of a mortal cosmos is not to last forever, but to be noticed, to be understood, to be cherished while it burns. When future civilizations, if any endure, look back at this brief era of brightness, they may marvel that the universe ever achieved such clarity of self-reflection. For us, the lesson is simpler. Live as though every moment is as rare as a star, because it is. Every sunrise, every discovery, every act of wonder is a defiance of silence. We are the universe's way of celebrating its own fragile light. So when we ask, is the universe already dying? The answer is yes. But it is also still alive, still radiant, still telling its story in the language of Starlight. We are part of that story. We are the witnesses, the recorders, the brief symphony before the long silence. One day silence will come, but today the stars still shine, and while they do so, do we.